Hi everyone, I'm Tamara Kahn, Program Manager for TMA Blue Tech. On behalf of the team, I just wanted to welcome you again to Blue Tech Week. It's our first day of the Blue Tech Summit and Expo. I'm delighted you're joining us for the water and wastewater track. We all know the world is facing a lot of water challenges right now, and Blue Tech Week is about meeting and connecting with the amazing water technologies that are tackling these issues. I hope you'll enjoy the programming we've put together. I'm certainly excited to showcase these incredible innovators and problem solvers. So, without further ado, let's get started on the first panel, dealing with salt.
You guys are live. You guys are live.
Okay, fantastic. Well, welcome to today's call. And what we're talking about today is dealing with salt. I want a quick introduction for everyone here, starting with myself, and then I'll let the others introduce themselves. Did my PowerPoint upload? Is that something you guys are seeing?
Yeah, I'm pulling it.
So I'll tell you a little bit about myself. I work for the Bureau of Reclamation, and I deal with the problems in the Central Valley of California. And in many agricultural regions, what we do have is accumulation of salt. My name is Miguel Arias-Paic. I've worked with the Bureau roughly 6 years. Next slide, please. So Central Valley of California is the world's largest patch of Class 1 agricultural land. And really what this says is there's basically to what it can do. It's really long and it fits in between the Sierra Nevada and the Coast Ranges, going from Redding to Bakersfield in California. It's really kind of ideal growing conditions. You rarely get any low or freezing temperatures, and you have 300 sunny days. And since the 1920s, they've been using groundwater irrigation, and they were drawing a source from really a sight unseen, and the farmers grew dependent on it. And really that kind of progressed, even despite the depression, where a lot of acreage was being irrigated by groundwater, and what they saw is a large drop in the groundwater table. Let's go to the next slide. So in the 1950s, the overdraft of groundwater was up to 500,000 acre feet per year. And what the Central Valley Project did, this is a Bureau of Reclamation project, it imported fresh water sources. So we diverted rivers from Northern California, Sacramento, Trinity, American, and San Joaquin. And these new river sources were irrigating a lot of, and water was pooling where it impacts productivity. So what was done was per pipe was put into the ground, and that's what got a lot of the salt actually moving out of the system. Let's go to the next slide, please. In terms of yield, there's really not much that can't grow there. So a third of all produce is grown, over 230 crops, many indigenous to Mexico, some English names. 85% of the carrots that we eat are grown there. So Bolthouse processes 6 million pounds of carrots a day. I mean, the numbers are just kind of mind-blowing. It's the largest production of canned tomatoes in the world, 1 billion pounds per week during harvest. Next slide, please. So what was the outlet for the drainage? In 1960, the San Luis drain was authorized by Congress, and really what the intent was is, look, we have no place to drain this water that's saline, so we're going to put it in the San Francisco Bay Delta. And between 1968 and 75 of the planned 188 miles were constructed. It stopped at Kesterson due to mounting costs, and there were concerns in water quality. And what ended up happening is this water started ponding and evaporating in the National Wildlife Refuge. Next slide, please. So what we didn't know stopped the flow. So there were early warning signs. Fish started to die, and really selenium was super high in the water, anywhere from 40 to 1400 microgram per liter. And it was bioaccumulating in fish and birds. And some of the fish had selenium as high as 100 times out of control areas. And really those are the only fish tested because all the other ones had died. A lot of birds were found to be deformed or stillborn within the eggs. And it took cubic yards and 9 to bury the selenium laments. And the flow really stopped, which indicated that we had to do an in-valley solution. Next slide, please. The solution was a demonstration treatment plant. It's a 200 gallon per minute osmosis selenium biotreatment, reverse osmosis to remove the salts, the biotreatment to remove the selenium out of the water. And they estimated at full build out in 2008, $2.7 billion would be required. And found is that we can actually remove the selenium pretty well, down to below 10 micrograms per liter. And the reverse osmosis, the intent was to send to evaporation ponds. This is an existing facility that's currently operational, and it's shown a big success story. So with that, you can go to the next slide, and we can have our next panel speaker talk and kind of introduce themselves. So let's go with
Joseph Gallegos.
Yep, Joseph Gallegos, please. You're up next.
So, hello everyone. Joseph Gallegos. I run a company called Umida AG. And next slide, or pull up my slide. So we're dealing with salt buildup in a number of different ways by breaking the cycle. Next slide. Basically, whenever you irrigate, a lot of us see this as this salting, crusting the surface after evaporation of irrigated water. And next slide. What's happening is, as we see it, is that as we're water from, in this case, either surface water, conveyance water, or well, and the whole idea is that the water's percolating down, or we're leaching it, and as we leach it down into the groundwater, that's that second slide where it's starting to build up, and then we pump that water back out of the groundwater and just kind of just making it more and more concentrated. So the groundwater is becoming more and more concentrated. It's this ending side of this loop that we have to break. Next slide. And that's where we break it at, right there where we pump it back out of the water, out of the groundwater. And that's kind of the technology that we're striving for. And we do it two ways. Next slide. This is what we want, and so there's no salt buildup. Next slide. And we use an innovative pipe to cut water consumption. This is our patent pending innovation. It's basically we deliver water subsurfacely. And by delivering it subsurfacely, we cut the water consumption by 20% currently, and we're shooting for 50% and plus in the future for years. And the whole idea is to deliver the water at the root level, so that way we eliminate the evaporation loss or the salt buildup. That larger pipe on the left-hand side, that's a quarter in the inside. So these are large pipes, they're not small pipes. And our first installations are actually going in this weekend. Next slide. So less water use means less salt. Designed mainly for orchards currently, but we know we're going to eventually go to row crops. And by the way, we deal in the Central Valley as well, so very familiar with that whole general area. Next slide. So the big idea is that because we cut the water consumption by so much, that typical desal technology is very high price. You know, it can run up to $1,000 per acre foot or even higher. If we're able to cut the water consumption or the water use within the agriculture area, then the price of delivery then drops to $500 an acre foot, or equivalent to $500 an acre foot. And some of the technology that we're working with other collaborators is solar concentrators and flash solar. That's where the water is coming up, it's being flash vaporized, and we're taking that desal or that desalination and using that water and having a zero discharge on the back end. So just the output is the accumulation of salt as a brine or as a thick slurry compared to going into a evaporation pond. And so that's kind of the ways that we're starting to really push the technology forward and cutting down the salts within an agricultural geographic area. Next slide. I believe that's Sam. Yep. Thank you.
Thank you very much, Joseph. And from here, we'll go to Yanik Nyberg. He's our next speaker.
Yeah, hi there, folks. I'm Yanik Nyberg, founder of Seawater Solutions. Really interesting to hear the conversations there around desalination and lower water use. We really come in from the other end of the spectrum, as salt really and seawater is our friend. So Seawater Solutions is a really agri-environmental ecosystems-based biotech company that pioneers seawater farming for climate resilience. You know, with 6 years left to avoid an irreversible climate breakdown, it's really time to address ecosystems-based and nature-based solutions to climate change and loss of biodiversity in agriculture. Next slide, please. And this is where seawater farming comes into play, because within 6 months we can turn degraded land and salinized farmland and polluted aquaculture sites into rich wetland ecosystems on which we can farm everything from salt-tolerant potatoes to halophytic species or naturally salt-tolerant crops like salicornia, while remediating polluted lands and capturing 30 times more carbon than rainforests without a single drop of fresh water. So how does this really work? Well, our systems feature renewable irrigation with IoT technologies, as well as specially bred crops to suit the needs of farmers, their land, and their market, wherever they are, from Scotland, where we're based, to Ghana, to Vietnam, turning wasteland into really the most profitable farmland in the country, with relatively low capital costs and high profitability. Now, these systems are fully automated and self-sustaining, meaning that once they are installed, farmers or landowners do not need to do anything but harvest, and we take care of the rest from farm to fork, offering these farmers access into various markets for these rather niche and novel salt-tolerant crops. And this model is key in mitigating the threat of risk to farmers, because there is that perception of risk in this relatively new field of saline agriculture, while allowing us to support throughout this process and generate recurring revenue. Next slide, please. And together with industry partners around the world and biotech partners, we have and are launching really some never before seen products, each falling within quite large industries, such as textiles grown without fresh water, first, from reed and other wetland crops, high value cosmetics from salty crops like salicornia, and biofuels, to really totally sustainable animal fodder from a whole range of eco-services like carbon credits. Next slide, please. And we started this year in Bangladesh, working in the Rohingya refugee camps with the World Food Programme, taking farmland that has been flooded by seawater and storms, and redeveloping now unusable land for conservation, flood remediation, and food production. And really, in a short period of time, within 3 months, we've been able to bring farmers back onto their land, with crops going to high-value markets in the region. Next slide, please. So we've scaled this solution and trialed it in over 7 countries now, from Ghana to Vietnam, and are looking to work with partners across the Global South and elsewhere to deliver this really game-changing technology of saline agriculture in particularly at-risk areas. That contains both coastal and inland areas, as salinization, as has been mentioned today, really spans the globe, affecting up to 30% of land. So please feel free to contact us if you have any questions or want to know more about this solution, and we're always looking for collaborators in the field. Thank you very much.
Thank you very much, Yanik. It was very interesting. And next is going to be Scott Reinert with City of El Paso. I know they have a lot of cool things going on there. So,
good morning. Can you all hear me? Good morning. Can you hear me? Okay, good. Yes. So want to talk a little bit about the desalination plant. It's not ag, but it does have the commonality of what do we do with salt? At this desalination plant, we have brackish groundwater that we could no longer use, and as a result of that, we decided that we build a desalination plant 15 years ago. The biggest challenge with, I believe, any desalination plant inland is what do you do with the concentrate? And El Paso was fortunate to have outstanding geology, which allows for deep well injection disposal of the concentrate. And I know when you talk about deep well injection, people talk about fracking issues, and they're concerned about seismicity. And in our case, the water injected is under gravity conditions, so it's under vacuum actually, so it works quite well for us. Next slide. So our desalination plant has a capacity of up to 27 million gallons a day, and we use 5 reverse osmosis skids, and typically we'll run producing 10 to 12 MGD, and we operate at capacity in peak capacity in 2012 and subsequently in 2013, coinciding with serious drought conditions where we didn't have any river water. Next slide. This is a picture of one of our reverse osmosis skids. The water that we are treating is about 3,000 TDS, and the finished water for our desalination plant for our customers is around 700 TDS, which I'm sure by California standards is kind of high, but that works for us out here in West Texas. The concentrate that we inject into the ground has a TDS ranging from 15 to 20,000 parts per million. Next slide. This map here, if I had one slide to describe our desalination plant, it would be this one. And we have, if you look at the yellow dots, those are our source wells. Those are the ones that have 3,000 TDS. We run those wells through the desalination plant, and then post membrane, we blend the water with those purple wells. Those are called blend wells. And in the middle of this, at the end of this process, we inject our concentrate. The injection wells are located 22 miles away, and you can see up in the top right portion of this diagram, that's where those injection wells are. The injection wells are drilled to depths of 4,000 feet. They're in a very fractured limestone that is not hydraulically connected to our drinking water supply. And the water out there is already 10,000 TDS, so it's not really considered a source of drinking water. Next slide. This is just kind of a schematic of what the disposal area looks like. We have the piping that brings the concentrate 22 miles across the desert to our injection facilities. We have a tank at each one of the well sites. The wells are down into like I said, 4,000 feet into a fractured dolomite limestone. It's through the fractures that the water is injected. In the absence of fracturing, we would not be able to successfully inject any of our concentrate. And we, when we built the plant, we studied evaporation and another thing called enhanced evaporation, and we found that the injection wells were more cost effective, and they are performing, they're exceeding our expectations in terms of their performance. So we have 3 injection wells out there, and in the next 5 years, we're planning to drill another well. And that concludes the presentation.
Very nice. Very interesting stuff for everyone. So do we have any from the audience? If not, I can definitely ask them.
We do have one question. I'm pulling it up right.
Okay.
All right, so I'm seeing the question here. Can you talk about the range?
So Yanik, can you talk about the range of saline, your crop systems? Basically talk about what it looks like.
So I think the question is about the salinity range that plants like. Correct. So really, there are 3,000 different salt-loving crops out there globally. So from mangroves all the way to spinach, which is marginally salt-tolerant, and barley. So from conventional crops all the way to coastal wetland crops. So really, what we use is over 30 different plants and species that could be used for agriculture and eco-services. So like the highly nutritious Salicornia varieties, a number of conventional crops that partners of ours have bred salt tolerance into, but the range that we can, as a company, work around is really everything up to around 45 DSM, so much higher than the salinity of seawater itself. and which is quite topical for brine and using brine effluent, because there are ways that you can use salt marsh species to actually decontaminate brine effluent. So the salinities or the variations there are very broad and allow for a lot of opportunity.
So in terms of the salt, that's kind of a follow-up question. Do you find that some of the plants that you put in actually extract, where does the salt end up? How do you deal with it? So if you irrigate with something that's super concentrated, super salty, you find that over some time the ground again becomes salty, or you have to drain it or flush it or something like that.
That's a good question. So the salt is primarily stored in the plants. When they're dry biomass, typically they're up to 30% salt, which is fantastic for different products like biosalts, which are nutritionally healthy in comparison, for high blood pressure, etc. In terms of maintaining a level of salinity to the right degree, there are a number of ways. Again, these are wetland plants primarily, but there's also really dryland agroforestry plants. There's a huge array of different species that you can use for all kinds of different salinization purposes. Really, it's about regenerative agriculture most of all, in terms of understanding the land you're working on. But currently, we've demonstrated that it works in deserts in West Africa, all the way to some of the rainiest parts of the world in Scotland. It's really about adapting to native species, breeding them for the right purpose, and away you go.
Okay, sounds good. And then for Yanik and Joseph, what partners would be helpful for you to be scaling up? It sounds like there's already some work done on this, so maybe I'll kick it to Joseph first, and then Yanik, if you could follow up on his response.
Our partners, ideal partners, would be anybody who has orchard type applications. It could be either in almonds, or pistachios, or peaches. That's our focus currently, in order to prove out the concept and show how we can reduce the water consumption. On the economic side, we actually find that energy utilities are drivers, because we cut energy consumption so much. We change the way that energy is being used on the farm from a long footprint of 72 hours down to these smaller 15-minute increments. So we changed the whole energy footprint when it was related to what's called the duck curve, overcapacity or overgeneration of renewable energies, and being able to utilize that. So that type of partnership would be ideal with a solar power plant or any type of solar integration onto the farm. So we can show the matching of the two.
Yanik?
Yeah, really, at the moment, it's the whole 9 yards. I mean, we work with public entities, international organizations like UNDP, commercial partners, universities. In order to scale, it's the whole trilogy there. You have really, it's about investment at the moment in this critical stage, about strategic partnerships with biotech companies to help develop R&D, universities. Really, it's expansive in terms of the partnerships necessary to really scale to the degree that we see this going over the next 3 to 5 years.
Sounds good. And if there aren't any more questions now, I actually have one for Scott. So Scott, obviously this is an alley. I use RO. I understand that there's some issues with it. Do you find it you need a certain amount of operator expertise, and is that easy enough to come by in the city of El Paso? What are your experiences with that?
I think that's a very good question. The water utility industry has expertise. We got it. Working with the echo here. The skill set needed for operators is acquired, and it's different than traditional wastewater. So I think after 15 years of operation, we've got a good skill set going. There's various agencies or societies, I should say, like the South Central Membrane Association, AMPTA. I've even taken some membrane classes. I'm just a project manager, but I find all those membrane techniques very interesting. So I think there is a growing knowledge about that. One interesting thing is as we look forward to using purified water, which is the treated wastewater, that also requires additional skill sets. You know, you're treating its wastewater plus desalted, desalination membranes, all these technologies. So getting skilled staff to operate this equipment is a concern. You know, at an engineering and planning level, we can say build this, build that, but if you don't have skilled staff to operate it, that can be a problem.
Thank you for that. And any other questions from the audience? If not, I definitely have a bunch.
There are no questions. So
Okay.
you guys.
So I'm actually going to Scott again, and this is about getting rid of the concentrate, right? It's always hardest for inland desal. What do you do with it, right? Do you find that you have any scaling on your pipeline, basically going out? And do you monitor for anything in terms of your deep well injection? In other words, is there anything that you're looking for that might be of a concern? You know, high selenium or arsenic or uranium or something that may concentrate in the water?
Well, a couple things. We have a permit that allows us to inject. It's only based on the quantity of water, not the quality. We have what we call an aquifer exemption permit that's granted from the EPA and the state of Texas. So in terms of, we're not governed by a quality requirement of our concentrate, which is good for us because right now it's about 15,000. It exceeds some primary standards. But as I mentioned, what we're injecting into is unusable in terms of meeting primary standards. So in my mind, it meets a perfect zone for injection. In terms of scaling, we're not finding any scaling. We did build a port in our plant that allows any kind of an acid to be injected into the concentrate line to break it up, or even if we felt that our injection well performance was decreasing, we would be able to add acid and perhaps break it up. We do use an anti-scalant pre-membrane, which has been very effective in terms of protection of the membranes. But in terms of seeing a scalant which is compromising our injection performance, we've not seen that. And just one other comment on our injection wells, the state is very regulated in terms of the injection well performance, in terms of how they're doing, how much they're injecting, the injection pressures. As I mentioned, we're injecting under vacuum pressure, which I'd like to explain to people that the earth is thirsty and actually wants our water, as compared to other injection scenarios where they're actually forcing under mechanical energy this water down into the earth. So we have very good geology for our injection, and simply put, we're not seeing any scale that's compromising injection performance.
That's fantastic, Scott. It's really good to hear that kind of, feedback from your end and that it's working out okay. Okay, my next question is for Yanik. And Yanik, in the Central Valley, we actually have reuse areas for crops, and the reuse areas grow what's known as Jose tall wheatgrass. I'm sure that you've probably heard of it. It's a common name. It does have a scientific name. I don't remember it offhand. But really, one of the things that it does is it uptakes selenium. And have you looked in your crops to really say, okay, we know we're uptaking salt and it ends up in the crop biomass, right? And in that mass of crop, what percent is maybe preferentially getting uptaken? Is there any concern over selenium or heavy metals, or are these things actually micronutrients that could potentially feed a population? Have you looked at things like that?
Yeah, certainly. It's a project by project basis. But again, these wetland halophytic species, typically in coastal salt marshes that we try and implement, they are fantastic phytoremediators and bioremediators. So of course there's a balance between nutritional safety and health and their functionality as bioremediators. So it's a case-by-case basis. Some species are ideal for, let's say, initial 6-month remediation and then followed by agriculture. And in most cases, it's really separated by case. But yeah, we do a lot of research on really looking at the the remediation task at hand, and which species can be best used for any given area.
I'd be interested in some of this because the selenium that's actually extracted out of the water becomes a useful trace element for cattle feed. So it's actually desirable where you don't have to feed your cattle selenium supplement if you can extract it out of the ground. And if you had something more efficient than, say, Jose tall wheatgrass, it would be interesting. So thank you for that.
That's right. I mean, that's right. I mean, that's the interesting thing. I mean, in terms of livestock feed and aquaculture feed, because of the nutritional value of these halophytic species, which is typically what's lacking in many diets that aren't by the coastline, because they do include iodine and vitamins and things to do with farmed fish. It's a fantastic alternative to aquaculture feed and also livestock feed. So it's definitely trials we've done to great success for health and supplements.
Okay, thank you for that, Yanik. My next question is actually for Joseph. And, you know, Central Valley is near and dear to my heart. And it sounds like you have a system that, you know, really aids the tile drainage in terms of your water usage, in terms of how you collect it. And that is really interesting to me. Can you talk a little bit about, you know, when you flash vaporize something, especially in the Central Valley, is there some constituent that you see precipitate out? And has there been a possibility of potentially reusing some of it?
Sure. So first, our particular application is actually, it looks like a drain tile, but we're actually injecting water compared to pulling water out, just to clarify that. So we're delivering water subsurfacely, what we call a smart drain tile, to create a moisture plume, our virtual water table. That's how that particular device is being used. As far as the flash scenario, with a number of professors on how the flash or the concentrate and the high sludge is then used for, in this particular case, we're using it for salt mining. So the salt mine entity actually wants the sludge to further treat it as a salt, like in borax or something like that. And we're taking the water and we're using that water to then use it for irrigation. So that's the application.
Okay, understood.
That's the application we're currently working on.
So in terms of the irrigation plume that you see, is it does it have to be a certain permeability of soil? Is that what you're looking for? Is there an optimal composition, or can it be applied really in any soil type, whether it be clay or, you know, like a sandy loam or whatever it might be? Is there something that you look for to optimize it?
We find that it's better, but it also works in sand. We've had the technology out for 4 years. We utilize it for urban areas where we take gray water from your shower or your laundry, and apply landscape. So, and we've done that for 4 years to show the proof of concept and work out the best practices. It happened that we ran into a farmer who says, "Hey, I would like this for my farm. Can you make a bigger profile?" And that's kind of where we're at right now, is that taking it from that urban application and taking it into the agricultural application. But in the urban application, it's pretty cool because every time you take a shower, you're watering your lawn or your grass, and you have a nice lush landscape without using any potable water.
Thank you for that, Joseph. And then a question for Scott. So can the salt be recovered and used? And is El Paso also looking at this? Maybe this is two questions then. One would be for Joseph, in terms of recovering the salt to use it for a beneficial purpose. And then is El Paso looking at this? It sounds like, you know, we're down to 4 minutes. El Paso is discharging the concentrate, and really it's being monitored, but you're not capturing the salt. But Joseph, please, the first part of this, please.
Yeah, what I would like to talk to Scott is figure out the cost per mega 1 million gallons, and how we might be able to look at that economic model and capture the discharge and utilize the water and just have that salt discharge as a whole different separate item as a zero output type voice.
Yeah, I think one of the big challenges is it's a huge amount. So please, Scott, chime in.
Right. So there's a couple of things. I got the echo. The byproducts recovery is a classic way of recovering or reducing your concentrate. We had a company called EWM in El Paso, Enviro Water Minerals, and their concept was to capture all the salts from the concentrate, sell it to various markets, including the oil industry for acids, for aquifer revitalization, caustics, milk of magnesia, cadmium, gypsum for ag, various purposes, and at the end of all this, there would not be any disposal needed. It's all market driven. Unfortunately, their concept didn't work as we had planned. We were partners with them. They were going to take a portion of our concentrate, and we've been having our fingers crossed, but just didn't work out. It's a complicated process in terms of all the equipment needed. It's well beyond RO. It's RO, nanofiltration, MBR. It's probably 7 different treatment technologies to get these salts as they wanted, and unfortunately, the company's not taking our concentrate as we had originally hoped for.
I'm curious, Scott, along those lines, what flow were they trying to treat?
The original plan was for them to treat 1 million gallons a day of our concentrate, and they would return the permeate back to El Paso water. And in the event that our plant was shut down for any kind of repairs or anything, then we had a brackish groundwater well, which they could use in their process and continuous stream of work. So we would continue to receive permeate from them. But as I understand, the project is kind of closing down.
Okay, we got 1 minute left. Let's see.
I could follow up on Scott's application.
Sure.
That
Take it up.
The volume that you're currently using, I could see that the way that we is agricultural production, and so that volume that you're discharging would produce approximately 1,000 acre feet of high value crop. In this case, maybe a pistachio or a pecan, and we would think about the revenue stream off of that first before the salt revenues. So that's the kind of the angle that we would look at this Scott application, looking at the water valuation.
Okay, I think with that, thank you everyone for your time. I think it was a very good panel. Nice job, everyone.
Thank you. Thank you, Miguel.
Thank you, Miguel.
Yeah.
Good morning,
Hey,
Mary.
guys. We're going to
Good
have
morning.
fun.
Indeed.
Hi, Mary. Can you hear me?
I can. Everyone can hear
Thank
me?
Yes.
Yep.
Yes.
Now it looks like we are live. So I just want to welcome everyone to our Blue Tech Week program on conservation and creation of water resources. It is a real pleasure to be here with a team of experts who are impacting 3 areas of water that we see as most critical for us to address. And if you could bring up my slides, the Global Waterworks overview, I just want to give people sense for why this is so important, what you're going to hear in the next few moments. And our team at Global Waterworks entered the water industry from the tech sector about 5 years ago. Oh, that's totally fine. Then we'll just, I'll talk through it because that's what we always do as we see in the water sector. What has happened is the water utilities, and many of you who work in water are aware that you've done your work so well that water is out of sight and out of mind because it's not even showing up on your balance sheets. The cost of water is so low. But we have infrastructure problems, we have contaminant problems, we have scarcity problems, and we have flood problems, which are creating pollution issues. And all of these mean that we're not doing well at managing our water. But the beauty is that technology innovation, most recently in the last 5 years, does enable us to have real-time visibility into our water resources, to fix about 30% of the water loss that's coming from leaks and just lack of awareness, as you'll hear from our speakers. And also, we've identified an additional source of water. Did you know that in Genesis, the Bible, for those of you who refer to the Bible, God said he placed half the water on the ground and half in the air. And until this time, we have not tapped the water from above. But we are thrilled to have 3 speakers here. I'm going to turn it over to them in this order next, and you can read their bios on the program. But Emilio Vargas, who innovated with Intellecy to provide a very easy and simple way for any homeowner or any building to sense their water use and to better manage it, and also detect leaks. And then Ramzi Bouzerda, who's here from Switzerland, is going to share his award-winning technology, which is now so useful as we're handling COVID and wanting to get a handle on hygiene in our bathrooms or in our water sources, and also better manage the energy in water, which is a real driver to efficiency. And finally, we're going to hear from Nick Harris of Watergen, 10-year innovator out of Israel that does bring the water from the air, assists the military. This is actually a strategic way to avoid wars, my friends. And he will talk about the ability to capture water anywhere soon with a home device that will allow you to also combat the purity issues in water. So I welcome you to this time, and Emilio, we'll start with you.
All right. Okay, let's see. Well, hello, everyone. My name is Emilio Vargas. I am the CEO and co-founder of Intellecy. And today I want to talk to you about leak detection as a possible source of water conservation. A lot of times people look at leaks from a damage standpoint, but today I want to share a little situation we had where it was actually conserving water, or was going to conserve water at the point that we found a leak. Next slide, please. So as Mary mentioned, we have 2 systems. One is intended for the homeowner to be able to manage their water, detect leaks, conserve water. The other one that we have is for buildings. And for the purposes of this discussion, I'm going to focus in on our building solution. So we have a smart water management system for buildings that starts out with an audit. So we go into the building and we want to find out where all the risers are, the main pressure lines that supply all the water to the building. The other thing we want to find is the feed lines that go to restrooms, kitchenettes, any other places in the building where water is being used. Next. So after we've conducted our audit, we come back and we place sensors throughout the building. The ones on the right, the purple ones, are the main riser in this building, supplying the entire building. The ones on the left, the restrooms, sit next to any use point inside the building to monitor water. Because we have all of these sensors throughout the building, we're able to get a complete picture of the water use and any leak situations inside the building. Next. So the two big things that we provide. The first one is early leak detection. Again, with having so many sensors throughout the building, we're able to find a leak early. And in addition to that, with the use of the use sensors, we can identify the location. Now, in the case of a visible leak like the one in this picture, that's probably not a big deal if people are there. But in this office building on a weekend or at night, it is a big deal for us to identify that leak early and then identify that location so you can mitigate the problems a little bit early. The second thing that we do is we monitor all water use. So we're able to trend usage and also set up some conservation goals so that water can be reduced and so that they can basically have a good complete picture of who the abusers are and who the rightful users are. Next slide, please. So I want to talk about a recent installation we had. This is one of our customers who installed our system. And just to give you a little bit to profile the customer, this is a 25,000 square foot building. They have 6 restrooms, a kitchenette, and a small gym with a shower. Next slide. We went in and we did our audit, we did our installation, and what you'll see here is in the center is our sensor placement. So there's no need to cut the pipe. There's no plumbing costs. It's done on a retrofit kind of. It can almost be a DIY. We do it only because we can find the ideal location to put these sensors, but there's not a whole lot of skill or labor required. The picture on the left shows the main riser. So because this was a 2-story building, we only put one sensor on the riser, and the one on the right shows an installation of one of the feed lines. This sensor happened to be the feed line going into the first floor restroom. As soon as we put that sensor in, we got a signal that water was flowing. We went into the restroom to make sure that all the water was off. We couldn't see, hear, feel, touch, anything. There was no water visible or anything that we can detect inside the restroom. We did a little bit of calibration in the field, and then we went back where we can do some advanced calibration via the server, and we also have a learning algorithm that can actually refine the signal a little bit more to make sure that we're not capturing any sort of environmental noises. This pipe happened to be near their warehouse where there's forklifts and a lot of other machinery going around. So we wanted to make sure that we weren't capturing something and having a false positive. Anyway, by Saturday, we still had water flowing. And the business owner also received an alert that water was flowing. We didn't quite know what the profile was for a leak just yet because it was a brand new installation. But we knew that water was flowing, at least we suspected. They sent someone in to see if there was actually a leak on a Saturday. And unfortunately, they didn't find anything. And the follow-on phone call was a little bit uncomfortable, only because they felt they wasted their time and they're not getting a good warm fuzzy about our technology. We decided to go in Monday. We ran more tests. We did additional calibration, and we realized that this system was actually detecting water. There was water going to that restroom. We brought in a leak expert, a plumbing expert with ultrasonic devices that can actually walk the line. And what they found was, next slide, please, is right in the restroom, right behind the wall was a same we're detecting. We were detecting about 0.4 per minute, about 1.5 to 2 liters per minute. And that's exactly what was coming out behind the wall. The the leak was corrected, was fixed, everything was taken care of, but we were very curious as to what was going on. Now this restroom is up against the outside wall. And next slide. And what was happening is that the leak, the water was coming out between that facade that's on the outside of the building. The restroom is right by that door. It was coming out and kind of working its way underneath that restroom. Now there's grass and shrubs all around there. So it was collecting and not really being seen, definitely not inside the building or on the outside of the building. But this had been going on for a while. So we were curious to find out how long. Next slide. So we asked the owner, could we take a look at their bills? And we found that this leak started about 7 or so months before we had installed our system. The initial increase on the bill was just ever so slight that really wasn't calling attention to it. But when we compared where the bill was currently versus where it was 7 months ago, it was about a $250 increase from 7 months till now. At the peak loss, which was kind of in line with what we captured of 0.4 gallons per minute, was about 20,000 gallons per month that they were losing through that leak. Now that seems like a lot, but because it was channeling in between those two concrete walls and working its way outside the building, there was never any visible water or damage inside the building. Just doing a little bit of math, we kind of estimated that over the course of the entire leak from the start to when we found it, there was maybe about 100,000 gallons lost. So, next. So what we found, or what we feel, is that the visible leaks, obviously, we can save on damage. But those small hidden leaks, like the ones behind the walls, underneath a slab, or somewhere where it can kind of work its way outside of the structure and never really causes any damage, definitely waste water. So from a conservation standpoint, we're preventing water abuse and water waste. And in this case, we definitely saved at least 20,000 gallons if the leak would have remained the same. But who knows how much bigger that leak could have become and how many more gallons they would have wasted in the coming months. Next slide. I want to thank you, and here's my contact information if you need to get a hold of me, or you can reach out through Hoover. Thanks, Mary.
Yeah, thank you, Emilio. That's great. We always want to conserve and avoid water losses. And that brings up our next expert here from Switzerland late at night. So Ramzi, I'll let you take it away. And if people have questions, by the way, post the notes and we'll get back to you, if not at the end of the session, in writing after. So yeah, go ahead, Ramzi.
Thank you, Mary. Do you hear me well? There is no lag? Yeah, okay. So I'm the founder and CEO of Droople. We are on mission to be the Intel Inside for water-based assets, which includes sanitary ware, water treatment systems, and appliances. And we have developed a full stack solution. And here we would like to present our smart sanitation module for schools. And it is very interesting during this very special period of pandemic with COVID to show that with water usage, we can actually leverage hygiene analytics and promote best practices according to hands hygiene. Next slide, please. Actually, you surely wonder why monitoring hands hygiene in schools. And I would like to first say that hand washing is a very important step to stop the spreading of any viruses that we can get on our hands. And it's a first, really, the foremost step to be healthy, actually. The second one is education for children, for students, how you can actually educate and increase the awareness related to a good hygiene, hands hygiene. And the last one is how giving a feedback to the users on premise can help to actually change their behaviors actually. And here we will see that not measuring only and providing data on a dashboard for technicians or for people that are managing the facility is good, but it's not enough if you would like to actually promote and adapt the behavior of your end users. And the feedback on a screen helped really a lot, because we have measured and we have actually scored the hygiene before putting the screen on premise, and then we have put the screen in the school, and we have seen a huge change in terms of behavior. Next slide, please. So actually, with our solution, you can enable water conservation, because we are able to adapt to any urinal, flush, or faucet tap, and we can actually also use this same data to compute a kind of hygiene score, and also compute the average time of hand washing. This is very important in a school, because you are in, I would say, in a population that is not porous, meaning that the same children come back and forth in the school, and you have to really protect this population with the contact with all the elder people, of course. With our solution, you can also enable up to 25% of savings, because we are able to benchmark any of your asset, meaning point of use, with water and energy consumption according to our benchmark, because we are already monitoring thousands of assets today, and we are able to provide if your asset is above the benchmark or below the benchmark. And then you can adapt your flush to reduce its consumption, or adapt the energy consumed by your faucet tap. Actually, in Europe, you can do that. Surely in the US as well, you can tweak a bit the valve of your faucet tap for hot and cold. The awareness, of course, is increased with the feedback, and you can provide non-intrusive transparency for the users, which is very important today, and adapt your prevention measures and communication in your school. And then you can also enable trust with your students. At the end of the day, if you are talking about big schools, here Vivalis is a small private school with 40 children in the basement, in the building, sorry. But for bigger schools, you can actually reduce as well your cleaning OPEX by up to 25%, because you are no more cleaning on a regular basis, but more on an affluence basis. And you clean only what has been used. And if it has not been used, you don't have to clean it. And this is a huge saving and a new way to actually provide a service, a cleaning service. Next slide, please. So, as I mentioned, we have equipped all the endpoints of the school. It was actually 11 endpoints, faucet taps, urinals, and flushes. And we have installed also a screen where they have a real-time feedback on their consumption. And today, all the children are looking at the screen every day once they are washing their hands to see if the score is going up, or if they are washing their hands also more than 20%, which is a best practice here in Switzerland. They have also a feedback on the total consumption, meaning that if you are required to wash your hands more frequently, it means also that you are consuming more water and more energy. We have converted the energy required to hot water in CO2, and here you have the total grams of CO2 related to this energy. Next slide, please. So now you can see the dashboard for, I would say, the facility manager who can really assess different type of metrics. You have the hygiene score, which is actually showed on the screen, but you have more detailed analytics on the usage of those assets. And you have here a breakdown per asset of water and energy. You can drill down all those dashboards. And you have also the affluence per hour on each asset or per space, of course. And here you can adapt your cleaning in order to avoid the contact with the people that are using those places. On the bottom, you can see that every flush or every faucet tap, you have the breakdown between water consumption and energy consumption. And you can then identify which asset is consuming too much and then act on it to reduce that footprint. Next slide, please. You are surely trying to know how it works. So basically, we have developed a hardware that can adapt in a twin mode for faucet taps, where we have two flow sensors with temperature sensor related to one communication module, which is called iLink. And for flushes or urinals, you have only one flow sensor with temperature related to the iLink. Here you need a plumbing work. We have estimated 30 minutes per asset to fix our sensor on it. It's completely IP68, so you can fix the sensor and then plug the iLink. You scan the QR code on the iLink and you register your device on the cloud platform and you are up and running. You will need also a Wi-Fi or a 3G connection with a gateway that will convert our LoRaWAN signal to an internet signal. Next slide, please. And I will end with the best actually testimonial that you can have from your own customer. And the MD of Vivalis has actually validated that they have seen significant reduce of absence of their students for health reasons, because they have increased the way and the hand washing of their students. And today, all those students are really motivated to wash their hands, but also to reduce water waste by actually stopping water flowing when they are washing their hands and run the water when they have to rinse their hands. And this is a very powerful educational tool, and I'm very proud to have helped this school to make it happen. Thank you. Next slide, please. And of course, I'm available at any time on the WOVA app, or you can contact me either by through my mobile phone or by email. Thank you for your attention.
Yeah, well, that's very exciting, Ramzi, and very fun. I was thinking if we're getting them to wash more, we're going to use more water, but you actually created a double metric there so that they save as they wash, and then they get scored. And you'll probably recruit many to STEM, hopefully, through that experience. And now, last but not least, we have Nick Harris, who's going to show us how we get more water, even where we don't see it. Thank you, Nick.
Thank you. Yeah, hello everybody. My name is Nick Harris, and I am the Vice President of Marketing and Sales for Watergen. And I'm very appreciative to the folks at Blue Tech Week and the Marriott Global Waterworks for the opportunity to kind of share our journey so far, and what a journey it's been. And thank you, Mary, for the biblical reference at the beginning of the panel there. Actually, Watergen is an Israeli technology company, and I think very mission driven. I'm not sure actually if you can just forward the next slide, and I can kind of walk you through the, no? There we go, perfect. And it's a very busy slide, but so Watergen is really a mission-driven business, and really have over the last 10 years perfected creating drinking water, potable water from the air around us, in the humidity from the air. So we've been at it a while, since 2009, and most of the focus for Watergen has been on medium to large scale deployments around the globe. And again, harvesting humidity and air into drinking water. Most of those applications to date have been humanitarian and disaster relief efforts, where we have crippled water infrastructure, or there's indeed a water stressed area, scarcity of water, or there's other issues with water availability. So that's been sort of the core of our efforts for the past 10 years, but it's moving. And I think sort of the deployments that we've seen, even domestically, we've helped out with stressed water areas in Flint, Michigan, and actually more recently, a children's hospital in the Gaza. So this kind of reinforces our core belief that it's a birthright of every human in this world to enjoy, the most basic human necessity of clean drinking water, regardless of where you live in the world, skin color, religious belief. So this is a very key part of what makes Watergen tick. We have about 184 machines and growing across the globe in about 45 countries. If you do go onto the Watergen website, you will see a lot of those deployments as case studies, so you can kind of double click on where those machines are. Just hit the next slide, please. So a little bit on how it works. And really at the end of the day, this is really nothing more, and I don't mean to trivialize it, than a super hyper efficient heat exchanger. We call it Genius. And essentially it's really like it seems. It's like you're harvesting the water that may appear in your air conditioning unit or in your air conditioner in your car, and that's sort of the core element, if you will, the killer app that powers all of our machines, all of our technology. And it kind of works like this. It's fairly simple. Air is drawn into our machines through some fairly significant blowers, and they're smart. They sense both the humidity and the temperature in the air, and adjust the cooling process to actually create water. So as air comes in, hopefully humid laden air comes in, it goes through a series of filters, air filters, that take out any large particulate matter. And once it hits that heat exchanger, that's when the water creation process begins. And from there, that's where the filtration starts. And there's a series of filters in all of these that filter out sediment and pre-sediment, as well as carbon filters, nano ceramic filters. And I think most interestingly is we actually, because the water basically is a distillate at that point in time, we're actually adding minerals back into the water. So both calcium and magnesium. So we actually do have the ability to adjust the pH of the water at that stage throughout the process. And then from there, the water basically goes into a holding tank or a reservoir, and it's continuously circulated at that point. And where needed, we can add an additional ozone filter in there to make sure that any biological contaminants are being dealt with. So next slide, please. So real quick, I'll just show you kind of what these marvelous machines look the one on the top left and the right, those are the ones which are doing most of the duty for Watergen at present. The one on the top left we would see as a solution for larger settlements, off-grid settlements, has the ability to create up to 1,300 gallons a day, which is quite a bit of water. The one on the right, the big blue, as if you would, as we would call it, that's what we call our Gen. This one's a little bit more robust. This is sort of our workhorse. This is the one that we would deploy to the military and to humanitarian efforts, those types of things, hospitals. It can be mounted on a roof, tied into a water system that can create up to a couple of 100 gallons per day. And I think the one that Mary alluded to at the beginning of the set was Watergen. We may change the name yet, but this is the one that we're most excited about, and ultimately kind of fulfills the portfolio of bringing water closest to an individual home or small business. And we're pretty excited about what that's going to mean in terms of the ability to bring clean, fresh, safe drinking water to people's homes. That can create up to 30 liters, roughly 8 gallons per day. Next slide, please. So I just wanted to kind of bring it together. As I mentioned on the site, we have a whole plethora of different case studies. This I felt really stood out because I think it kind of very emblematic of not just what makes Watergen, but really a real solution to a real grave problem. And this elementary school in Chile was unfortunately receiving some terrible quality water, and in Chile, for those who may not be aware, the water quality is very impacted by a lot of mining and discharge, and the some of the issues with the quality of water are pretty significant. So we actually put a machine in this school, and you can just see some of the images there of how that is helping those students. This machine actually created about 500 liters per day, and really was a more of a test actually to sort of demonstrate the technology and how it's quite easy to scale. So basically, you can just plug these machines in this case, in a 3-phase power source, and it begins its water creation process almost immediately. So moving forward, this is going to be a key focus for Watergen, is to optimize both the efficiency and the technology that is in all of our machines, and furthermore sort of scale it in terms of how we help larger communities and settlements and larger populations access good, clean, fresh drinking water, but as well as taking it down into a sort of a smaller environment where we're very proximal to where the consumer is and where people live. The other piece which I failed to mention is that we are very active in the mobile space as well, working on automotive solutions, both private sector and public sector, to bring water into transport, be that public transport and private cars, RVs, that type of thing. So our goal ultimately is to try and bring this technology as close to where people are at. And that's what kind of excites us and gets us up every day at Watergen. So that's the Watergen story. I appreciate everybody's time, and would love to, if anybody wants to reach out to me, feel free to do so through the Hoover app or via Twitter or LinkedIn and so on and so forth. So thank you. And thank you, Mary.
Yeah, thank you. Oh, perfect. Because yeah, well, I just want to recap just what we've heard, because it is so significant for people who are looking to get smart about their buildings and their water. You heard about Emilio's solution as well as Ramzi's. And then for people who want to address hygiene in these COVID times, it's amazing how getting smart about water allows you to handle maintenance of bathrooms around a whole, enterprise, or else to augment water with pure water. And I had the opportunity to drink from Watergen's solution, and it's totally amazing, guys, when you have pure water that is remineralized. And Israel has experience like no one else in how to handle augmented water. So before I ask each one of them to share a final comment on what their aha has been in helping people use their solutions, I'd just like to say everyone is welcome to learn more about these solutions and any smart water technologies that are making an impact in our Global Waterworks Connect showcase. It's gwwconnect.com. And we're really pleased to have Droople and Watergen and many of these technologies helping to sponsor that community collaboration so people can get comfortable at their own speed. But gentlemen, we go in reverse order now to hear Nick, if you could share the aha in implementing water that you think people might want to know about. We've introduced the atmospheric water.
There's a couple. There's in this with the atmospheric water. There's been so many ahas. I think for me, it's the myriad of applications. There's no end to where this technology can go. We have to focus in a certain way. But the applications are almost infinite, and that's a bit of an aha for me. And I think the second part of this whole thing is, which we didn't really mention, I didn't mention, is the impact on plastics, and the technology we have around water creation it's going to have hopefully a very positive impact on how people don't need to lug plastic containers, water bottles all over the place. So bit of an aha for me, and those things are a key part of how we move forward.
Great, those are great ahas. And Ramzi?
Yeah, my aha, I would say, I didn't wonder that we can really extract such very insightful quality metrics on water usage. And I think we are really at the beginning of understanding how water consumption or water behaviors can really provide very insightful information and leads to better conservation, but also better value and management. So Drupal is really at the beginning of the story, and we are really amazed and really excited to be part of this great journey.
Mm-hmm. Yeah, with many awards, and you're looking for a California partner pilot. So if there are people out there who are working in water efficiency, Drupal's proven in Europe, but needs opportunities here in California. So that is good. And then Emilio.
I'll be quick because we're running out of time. I think my biggest aha is how people don't know how much water they're actually using. Kind of building on Ramzi's comment there, just knowing how much water you use and how much water you waste is mind-boggling when we bring that up to some individuals. That very same building that we found a leak in, they have a shower there, and they use the shower for, on average, 25 minutes per shower. And that's mind-boggling. A shower should not take that long. So when we bring that to their attention, just the sheer knowledge of knowing how much water they're wasting and abusing really starts to shift their behavior and their mindset, because the price of water won't do that. It's got to be people really knowing their numbers and paying attention to start trying to drive conservation.
Yeah, very good point. So very fun to be with you all. Was there anything, any final comment before they ding us and shut down the screen? Make sure you track these people in the Whova app. But we have 40 seconds. Who wants to grab the microphone? Is there an ask, Nick? Is there an ask from Israel and Watergen for the folks on this conference?
I'm sorry, Mary. Is there an app?
An ask, like a request that you would have for the people in this conference. They're dealing with hurricanes. They should trial water.
Yeah, I think an open mind. I think learn a bit more about atmospheric water generation, and we're more than happy to provide you with what we're doing and how we think that this is going to impact the future. So, but be in touch, I think, is the biggest one, and we can help.
Yeah. Thank you all, you guys. Great work. Love your
you.
technologies. We'll see you in the Global Waterworks Connect.
Thank you. Thanks, Mary.
Thank you.
Hello, everybody. I'm Peter Fiske, and I'm here to lead our panel on desalination. Desalination is receiving more and more interest as we consider the limitations to water supply across the United States. And of course, the maritime community has known of desalination for a long time, not just because many small desal facilities operate on larger vessels, but also because many of these communities where we have strong maritime activities are themselves utilizing ocean desalination as part of their water supply. Today, we have a great panel to discuss the opportunities for desalination in the 21st century. On with me is Eric Dole from Garver, Michelle Powelson from Poseidon Water, and Gil Dhawan. We are all here to talk desal, friends. So I'm going to begin with some of my initial remarks, and then we will we'll proceed with each of you, and then have a roundtable discussion at the end. Sound good?
Sounds good.
Good. Well, let's pull up my slides, and I can begin. Well, hello, everybody. My name is Peter Fiske, and I am Executive Director of NAWI, the National Alliance for Water Innovation. Next slide. NAWI is a Department of Energy funded research program, a major investment that the federal government is making in early stage applied research to lower the cost and energy of desalination and associated water treatment. The 5-year, $110 million program is engaging researchers from across the United States to look at ways of not just implementing today's desalination systems more efficiently, but novel methods to take water and take salt out of water, and also potentially harvest other valuable components out of brine streams that are either too salty to process or water supplies that previously have not been economical to use. Our goal is to utilize these non-traditional waters, these waters we've previously been ignoring or throwing away, and desalinate them for a secure water supply in the future. We have partnerships with several national labs, the Electric Power Research Institute, and several California agencies. Next slide, please. So a research hub typically involves a core group of researchers, and that's certainly the case here. Tab forward. But we've surrounded this research consortium with a larger alliance. And the alliance is a membership organization, no cost to enter, and it engages the entire desalination community, researchers, nonprofits, state and federal agencies, to try to create an environment where the alliance can feed great problems into the research consortium, and the research consortium can make progress. Next tab. Of course, on the research consortium side, we have some of the leading universities in the United States who have been doing cutting edge work on desalination. Next tab. And in the alliance, we have literally over 300 companies and organizations that somehow touch the water sector. Next slide. There's 6 key research elements that we have, of course, used to form an acronym called A prime. These 6 key challenges we believe are going to advance desalination in the 21st century. It starts, next tab, with autonomous operation. Developing new technologies to enable our treatment systems to run much more autonomously and much more reliably. Next tab. The next P stands for precision separations. Present desalination and water treatment technologies are very blunt force. They strip out all the cations and contaminants in the water, including stuff that's benign, like calcium and magnesium. We need next generation separations technologies to precisely isolate and remove the key problematic constituents for the particular water use that we're going to engage in. Next tab. R stands for resilience. The 21st century water systems need to be much more resilient, able to turn on and off and potentially even respond to changes in the cost of electrical energy. Next tab. I stands for intensified brine management. As many of you in the desal business knows, desalination is a wonderful way to produce clean, fresh drinking water, but it also produces these concentrated brine streams. When you're away from the coast, you can't just mix it back in the ocean. So we need new technologies to take these intensified brine streams, extract all the water possible, and maximize the value of these components. Next tab. M stands for modular. Today's reverse osmosis and membrane-based separations technologies are inherently modular, but many other aspects of our water treatment are actually quite custom built each time we build a new treatment plant. We need to modularize the entire treatment train and develop ways that we can rapidly mobilize and deploy entire treatment trains in novel environments. Next tab. And finally, electrification. With the tremendous decrease in the cost of renewable energy, electrification is going to be a key goal for many industries, including water. Not only can we push today's treatment strategies to utilize much greater fractions of electricity as opposed to heat, but many of the chemicals we're using in desalination have a high energy, sort of embedded energy component to them. We can potentially innovate and make new technologies to generate treatment chemicals on site and on demand. Next slide. Our vision is that each of these 6 A-prime challenge areas will individually contribute to lowering the cost and energy of desalination. But when we bring them all together, we enable something very important, and that is, next tab, the ability to utilize desalination in many more localized environments. In other words, by locally retreating and reusing water and desalting water at the point of its generation, we can remove the cost of moving water around and thus issue a new era, much like photovoltaics, where we still have centralized power generation, but many of our houses also have photovoltaic panels augmenting the power supply on our roofs. Next slide. Next slide. So finally, in my presentation, I just want to alert the community to some asks we have. Next tab. The first is relating to our community. As I said in the beginning of my slides, this is your hub. The number one way you can make it work for you is by engaging. Next tab. We have, as I said, the NAUI Alliance, which is a no-cost entry to join the program and to learn about our research. But do remember that the hub is focused on early stage, relatively low TRL technology readiness level research. Next tab. I will also say that one of the things that really frustrates academic researchers is that the most valuable data exists in today's water treatment plants. We need partners, next tab, who can give us access to operational data and who are willing to partner with us so that academic innovators can utilize the data to potentially develop, for example, new algorithms using machine learning and artificial intelligence to better control water treatment systems. Next tab. And then finally, as a community, we need to continue to advocate for federal investment and for research support. 50 years ago, actually 60 years ago, the Kennedy administration embarked on a bold vision to lower the cost and energy of ocean desalination, and they created the Office of Saline Water. Today, the Department of Energy has made this next investment, and we need to encourage them and other federal agencies to continue to invest in a resilient water supply for the 21st century. And that's it for now. Next slide. You have the information on the NAUI website, nauihub.org. You can go there and sign up to join the Alliance, and I look forward to seeing you at future meetings. Thank you very much. Who's next?
I think I am.
All right, Gil. I'm sorry, Eric.
Yeah. I think.
No, they'll give a few minutes. They're just loading up your slide.
Okay. Cool. Okay. Thank you, Peter. Start my clock. All right, I'm going to talk today about an innovative cooling tower blowdown treatment scheme that kind of touches a lot of the A-prime boxes, especially with electrification and modularization. We are treating a cooling tower blowdown for the Red Rocks Community College, which is right next to the Bureau of Reclamation. We were awarded this pitch to pilot grant money, and we started last month with our electrocoagulation, ultrafiltration, granular activated carbon reverse osmosis with vacuum assisted concentrate management blowdown treatment. This is a ZLD system that we're going to pilot, and we're going to see if we can ultimately take the salt slurry out of the VAED system and use it in a circular economy to make on-site sodium hypochlorite while returning the permeate back to the cooling tower. So next slide. We're going to talk about the problem, our team, and the solution, which was our pitch. Next slide, please. The problem, next slide, is salt. It comes everywhere. It comes from agricultural, it comes from actual chemistry that we add to water treatment plants, to wastewater treatment, to concentrate from membranes, to ion exchange regenerant, spet regenerant, to water softeners. Basically, all these dark orange arrows are representing how salt gets into the watershed. And we're going to focus, as you can see, on commercial cooling tower with this research. Next slide. This is one example for the Palo Verde nuclear power plant in Arizona, where they take, it's the largest cooling power plant in the country at 4 gigawatts and the only one in the world to take treated wastewater for cooling tower blowdown. And they recycle that 25 times. You can see the TDS coming in is about 1,000 and going out is 25,000. Next slide. Our team, next slide. It composes of, we have Dr. Mike Mickley. Don't need to say much more about him, just Google him. He's a brine concentrate management, has issued a ton of research papers. We're fortunate to have him on our team. Red Rocks Community College, Dr. Michael Watts, which is Garver's water reuse practice lead, and myself as the water and energy practice lead for Garver. Next slide. Our solution is next slide. You can see here, we're just essentially taking the spent blowdown from the cooling tower at about 25 pounds per day of TDS loading to the local sewer shed, and we're intercepting it and putting it through our treatment train that we can see up there in the trailer, and then we're going to take the permeate back to the cooling tower, and the blowdown will go on to the, there you go. And you can see right there, it comprises of EC, UF, GAC, RO, and then the permeate comes back to the cooling tower, and the blowdown goes to vacuum-assisted electrodistillation. So we're electrifying the front end, where we're taking out all the divalents and the silica and everything that would otherwise foul the membrane system, and it's also going to increase the RO recovery. We can push it really hard and send a high TDS water. We're going to concentrate it up to about 36,000 ppm TDS for the VAED system, and I'll touch on that in the next slide. So the EC, it precipitates everything you don't want to hit the membranes, essentially. That's the theme of this slide. It also, anything biological it will take care of, and basically sending the RO system a sweeter sauce, for lack of a better word, so you can get a higher recovery and really stress those membranes. Next slide. This is some of the bench testing we've done here at Red Rocks Community College on wastewater, and you can see it does a very good job of separating the primary influent to the clarifiers for a very large wastewater treatment plant out here in Colorado. Next slide. You can see the recovery, it does very well. Just with the EC and 11 micron filtration, we got 99% phosphorus removal, silica removal, and the TDS went down significantly. As we push that pH a little bit higher, we can get a 95% hardness removal. We get about 5 log removal of fecal as well from this without any chemistry. Next slide. This is what the membrane system looks like. And this is basically just to remove any pin flock that may get through from the EC before it goes to the RO. And then the RO is going to go through 2-stage RO, and the permeate goes back to the cooling tower. Concentrate goes to the vacuum-assisted electrodistillation. Next slide. Next slide. Yeah, keep animating. Next one. And this is the vacuum-assisted electrodistillation. Essentially, you pass an AC current through brine while you're pulling a vacuum, and you can essentially flash the brine at a significantly less energy intensity than traditional multiple vapor compression systems. And this one right here, there's a video embedded. I don't think it's going to play, but we took 120,000 TDS to 60 ppm at 114 degrees with 1 kW input. So this is going to be, we have to do some modifications to get to the 4 gallon per hour for this cooling tower flow rate. Next slide. Keep going until you get to. And we're ultimately going to take this spent brine to make a circular economy, talking with Microplo right now to possibly send this salt slurry to them and see how they can make it into on-site sodium hypochlorite that can be used in the cooling tower. Here's a quick animation of how it works in the VAED system. Keep tabbing through it, if you don't mind. Fill it up with the hot brine. You have cooling tower bath, pass electricity through the electrodes, flash it. It distills, steam happens, occurs up through the tube, condensate occurs from the heat transfer, and you have distillate, and the salt brine comes out the bottom. That being said, that's it. And if there's any question, I'd be glad to happy to answer them. Thank you.
Great, thanks, Eric. That's really exciting work that you guys are doing, modularizing ZLD systems. Excellent. Next up, I think we'll have Gil go. Gil, can you tell us a little bit about applied membranes?
Hello, my name is Gil.
Yeah, they're going to move your slides over. They'll move your slides over in a second.
Yes. Hello, my name is Gil Dhawan. I am the CEO of Applied Membranes. It's a company that has been around for 37 years, and we are basically doing the kind of things that both Eric and Peter described in terms of applying them in real life. And you see next slide. The company is basically takes all the technologies that are available and applies them to create systems that can actually produce the water from every kind of wastewater or source of water that there is to make it into water that we can use. Next slide. We started applying membrane technology in 1983, and we do all kinds of pilot experiments to see how well we can economically apply this to make it worthwhile for people to actually use. This is where we really spend our time to take the kind of technologies Eric and Peter described that can be put into use. Next slide. Our systems to treat water have been working in all kinds of places all over the world in very difficult situations with very difficult waters. We are in over 100 countries now applying these systems. And most of the time people come to us not for the simple applications that reverse osmosis can do, but for the applications that require more design or engineering or chemistry input to make them work. Next slide. Here is where what Eric also described our challenges. We have in membrane technology basically to make desalination be economical, we have to bring the cost down and also reduce the wastewater. Those are the two challenges. And for that, it's always the membranes that are the key part. Membranes have to perform to make this happen. So for example, the pretreatment that Eric described is the kind of pretreatment we need to make the membranes perform at their highest level. And that's what one challenge. The other challenge is how can we take the concentrations of the TDS, total dissolved solids and membranes, to the highest level? And that's a challenge that we have been able to cover by having a very high pressure membranes that can now run up to 2000 PSI. So the main thing that we have focused on in applying these, and I'll show you some of the applications and case studies, is membranes that are being developed now. And as Eric described, maybe they can be ion specific. Maybe they can be such that the osmotic pressure doesn't play a role. Or maybe we can modify them somehow to produce water without having the challenges of membrane fouling. These are where the membrane research is going on. We have used membranes now that produce very high flux, that is, productivity of the membrane is high because of the new construction or modifications of the membrane chemistry or adding certain ions or compounds within the membrane formulation to increase the flow through the membrane. What that does is we can now run membranes at lower pressures, meaning with the lower energy consumption per gallon produced, and we can make the system at a lower pressure. The other thing that the membranes have been done in the membrane research has been done is to make them fouling resistant. The main thing that we need to make sure is membrane performs at its higher efficiency for the entire length of its life, and that creates a lower cost of membrane replacement. The second part, which is reducing the amount of concentrate going down the drain or wastewater, like Eric mentioned, that you're in a desert, there is no place to put the concentrate. In fact, we have just started up a system in Palm Desert doing exactly that. There is no sewage line, there's no drain line. The city required us to make sure there is no wastewater. And so we have an example of that. What we have done there is concentrated the water using the membranes to very high concentration, and I'll show you this in the next few slides. And then the final concentrate was dried by using an evaporator to solids. So the two things that have to make the membranes more economical, more practical, are the membranes must perform as best as they can and for as long as they can. So that's the membrane part of it. And then how can we make them run at very high pressures? So that's the equipment design, the ability to run at high pressures, and then collect the concentrate to further dry it. So in the next slide, I show you an example here of seawater RO system with energy recovery. The systems of seawater desalination require very high energy input. Now, there are ways to reduce it by proper membrane and better membranes, but also we can recover the energy of the water that is still at a pressure before it goes down to drain or before it goes down anywhere to be further concentrated. So that's the energy recovery example. The next one is, the next slide shows we have taken the industrial wastewater, and by proper pre-treatment of ultrafiltration and microfiltration, we are able to recycle this water. This is where the pre-treatment makes all the difference. If we have more elaborate pre-treatment that will make sure the membranes won't foul, pre-treatment that makes the membranes work in the first place. This is, membranes are now using ultrafiltration and sometimes nanofiltration as a pre-treatment, all to increase the amount of water we can extract from the same feed water. The next slide shows again the kind of pre-treatments and membranes that are available: microfiltration, ultrafiltration, nanofiltration, and also then you need to develop membrane cleaning chemicals. We want to extend the membrane life to as long as possible because they're the expensive part of the total investment. And so that is another area where we keep working on how to make sure if they somehow foul, we can recover them. Next slide shows, as Eric mentioned, there are, Peter mentioned, there are all kinds of applications for membrane desalination, all kinds, from agriculture to beverage to boiler feed water to rinse water to chemical processing to disaster relief to food and dairy processing, seawater desalination, pharmaceutical water, microelectronics, and then pilot plants and other things that we can provide to test these different applications. Next slide. This shows, again, industrial recycling of the water, but using containerized systems, which, as Eric mentioned, modularizing the whole process makes it faster, less expensive, and eventually a very large plant is nothing but multiple of the same smaller modular plants that can be moved around easily. And then the next slide shows, this is where We use nanofiltration as the pretreatment to the seawater, to the brackish water. And we had, the goal was the minimal liquid waste discharge, or what some people call near zero liquid discharge. We used ultra high water recovery. We took the recovery, that means the amount of water produced that was desalted water was 96%. Only 4% of the water was concentrate, which was then evaporated. This is obviously the right thing to do, to not have to deal with the concentrate. And if we can make the membranes produce more water from using the same kind of treatment steps. The pressure used there was 1500 psi. We took it all the way to up to 1500 psi. It takes two steps. We do the normal desalination, and the concentrate is produced at 75% recovery. Then we take that concentrate and go through what we call as RO concentrator and take it to 96, sometimes 98% recovery. There are some tricks to be played in terms of chemistry of the thing, chemistry of the water, but overall processes now can be done all the way to 98% recovery with some adjustments to pretreatment. The pretreatment is the key thing here because, as Eric mentioned, that changes how far you can go in concentrating the dissolved impurities in the membrane system. Next slide. It shows again where membranes were replaced as pretreatment instead of the media filters that are normally used to increase the recovery. Next slide. Here is the other part of energy that we have to be looking at. And we have developed systems that work on solar energy. We supplied 350 systems to Middle East for producing water for 350 villages, all working on solar power. So this is an area where the modularizing and using solar energy where possible. And these systems cannot be very big, but we have made systems that work entirely on solar power. And next slide. This shows, again, mobility of a system. These are systems for disaster relief, and also military has used them, where they are ready to be used on any source of water. They're called NBC, Nuclear Biological Chemical Contamination Removal Systems. And these are, again, all membrane-based with other treatment steps mixed in there. Next slide. This shows another groundwater remediation system which uses ultrafiltration, UF, and reverse osmosis. Same idea, just showing you another example. Next slide, and I think that is all I have to say. Thank you. I think with all the things that I heard today and what we are trying to apply in the real life, there is a big future for water conservation and water reuse. Thank you.
Great. Thank you so much, Gil. That's a great gallery of success stories for you. Well, of course, there's always the big daddy, ocean desalination at scale. And here to talk about that is Michelle Powelson from Poseidon Water. Poseidon, of course, is the developer of the Carlsbad, the Claude Bud Lewis desalination facility in Carlsbad, California. Michelle, tell us a little bit more about the work that you all are doing.
Yes, thank you very much, Peter. As Peter mentioned, my name is Michelle Powelson. I work as a senior environmental scientist for Poseidon Water, and I am based out of the Carlsbad desalination plant, which I will be talking about today. Next slide, please. So just to give you a little bit of background on Poseidon Water. Poseidon Water is a leading US water infrastructure developer and investor. It was founded back in 1995. It's currently headquartered in Carlsbad, California, and we really specialize in public-private partnership, focusing on project development, finance, and long-term operations, maintenance, and management for projects. We do implement state-of-the-art technologies in our projects, management expertise, and innovative financing solutions for our projects. What we're most well known for right now is we are the developer and project manager of the award-winning Claude Bud Lewis Carlsbad Desalination Plant, and we are currently in the permitting phase for the Huntington Beach desal plant up in Huntington Beach, California. Next slide, please. So just wanted to focus real quick on some sustainable development goals that we practice, and just a couple of the main ones that we practice in our projects. So clean water and sanitation, of course, seawater reverse osmosis water from CDP, or the Carlsbad Desal Plant, provides nearly 10% of the drinking water to San Diego County, which is huge considering that the rest of the drinking water for the county we mostly import. And desal represents a drought-proof, locally controlled water supply that has led to improved system-wide water quality, and I'll actually be touching base on that in a future slide. And then, of course, partnership for the goals, for the Sustainable Development Goals. We're in partnership with NAUI. We've been in partnership with them for a few years, and really working with the researchers and the innovators part of this group to further desal technology and improve it. And then, of course, the Lawrence Berkeley National Lab as well, and other industry and academic partners. Really want to focus on these partnerships to further improve the efficiency and overall performance of desal. It's here to stay, and we see the need for it in so many places, of course in California and Southern California, but all throughout the world. Next slide, please. So just to focus on the Carlsbad Desalination Plant, we are a 54 million gallons of water per day seawater desal plant. We have a 10-mile pipeline that connects, we connect with the San Diego County Water Authority. They are the distributors of the water. They are our client, but we provide the water that they distribute throughout the distribution system for the county. To date, we have delivered a little over 64 billion gallons of water to the county, with being online for just less than 5 years. We're very proud of that, and of course hope to continue to deliver more. Our delivery method here is we have the design, build, finance, operate, maintain, and then transfer. The plant itself provides enough water to serve approximately 400,000 people per day. As I mentioned before, this is the county's largest single local water source, which is huge for us. And then overall, we provide the experience and assets necessary to develop, pilot, scale up, and implement new and more efficient water technologies. Having a plant in operation to test these new technologies that are being developed and will be continued to be developed. It offers a lot more insight now to apply, the small scale, bench scale, if you will, studies now to the real world, and see how they scale up, in an actual desal plant here. And then as a side note as well, the CDP we were the first desal facility that was approved under the new California Ocean Plan, which is a very big accomplishment. We worked very hard with California water boards and our assigned staff members and various other folks here to make sure that our facility was not only state of the art, but also complied with the new California Ocean Plan. And we received that permit back in 2019. Next slide, please. So just wanted to focus real quick on what water quality improvement we are seeing here. This is just a chart that summarizes a few key parameters here, looking at Carlsbad desal water in blue versus Metropolitan Water District, which is the imported water that San Diego County receives as well. And so you can see now in all these parameters here that we've reduced the hardness of water, reduce alkalinity, TDS is down. We know that RO technology is so great at removing pretty much everything. Of course, there's the balance of that. You do still want some of those things, but overall, we have seen an improvement in the distribution system, and our the customers and just, if you will, local residents who are receiving the water, they have commented many times and just noticing a higher quality water in their taps and wanting to know how they can access it more and why there aren't more desal plants around. So there's definitely an interest and a need for this technology as it continues to develop. Next slide, please. So just wanted to go over a little bit of what we are currently working on at the desal plant. Technology and pilot studies are continuing to be looked at and worked on as well, and improving the efficiency of different treatment steps. But right now, we are in the middle of getting ready to start our pilot study for our new intake screens, which are required under the new California Ocean Plan amendment that I talked about earlier. So here we have our site for the plant itself, beautiful San Diego County, but up in Carlsbad, which is the northern part of the county, overlooking the Agua Hedionda Lagoon and the Pacific Ocean. You can see the intake there at the bottom from the ocean. It goes into the lagoon, and then our intake pumps are on the southern end of that lagoon there. Next slide, please. So right now we're transitioning to standalone. The plant itself, when we built the plant and began delivering water in 2015, we were coupled essentially with the Encina power plant, also located off this lagoon. And the reason why we chose this location for the desal plant was because the existing infrastructure was already there from this power plant. They already were pumping water through the power plant to use for once through cooling, and then cycling through their system, discharge back out to the ocean. So we utilized the existing infrastructure that was there and essentially tapped into their discharge line for the power plant, and then diverted some of that water up to the plants, which ended up being a great tool. Unfortunately, not everything lasts, so the power plant is shut off now, and therefore those pumps are shut off as well. So we're in the process of transitioning to standalone, since we were previously using NRG's pumps, or Encina Power Plant's pumps. We just went through a construction phase where we installed our own fish-friendly pumps in the lagoon itself. And go to the next slide, please. You can see, perfect, thank you. You can kind of see the water path is still the same, but essentially instead of the water traveling through the power plant's system, we created essentially just a blockage where the water kind of gets diverted, almost makes a U-turn. As it goes, it's pumped through our fish-friendly pumps. We're still using some of the traveling screens, the NRG power plant that they had as we get ready to conduct our pilot study for wedge wire screens out in the lagoon. Can you go to the next slide, please? So ultimately, this pilot study it's a 2-year study that we'll be starting in the next month. That has 1 millimeter wide wedge wire screens, which is a requirement under the California Ocean Plan. Since we were the first ones to be approved, first desal plant to be approved under this, we're also the first ones to try this technology out in this environment. So hence we're doing a very thorough 2-year pilot study to determine the best available technology to be using for these screens. We're testing a couple different types of screens to determine what works best in the lagoon environment. But ultimately, you can see out in the middle of the lagoon there, we'll have our screens there that essentially will allow water to flow at a very, very slow velocity, so no fish will be sucked up, if you will. They'll have the ability to swim away, and that's also a requirement under the California Ocean Plan. And then they'll come in, then the water will come to our intake pumps that were recently installed, and then come back up to the plant. So these new developments will be finalized now. We're hoping come 2024 is really when we'll see all of this come to fruition and be complete. But these are some of the big projects that are currently taking place at the plant. And with that, once we have our new intake pumps, new intake screens in and everything, we will be able to further increase our production as well. We can do this at any time really, but thanks to the improvement in development of RO membrane technology, the RO technology improved now just in a matter of time from when we originally designed the plant to when we came online, just a matter of a few years. So we're seeing that technology improve quite rapidly. And that has allowed us to actually still use the same square foot, still use the same area for our RO membranes, the building itself, but we're able to produce more water out of them because we're able to fit now a larger area of membrane in the vessel itself and therefore filter more water. So we're working on that improvement as well, and eager to see all this come together. Next slide, please. And that's it for right now. I'm happy to answer any questions. I just thank you all for your time and interest in this exciting topic.
Thank you so much, Michelle, and great to see that the innovations in membrane technology lead us to be able to wring out even more performance in an already outstanding world-class facility at Carlsbad. Well, everybody, we've run a little bit long, so I'm going to close us out for now. In the conference, we will be taking Q&A, so we're going to move into that right now. But from our four speakers, thank you all for sharing the latest on desalination and its bright future ahead. And everybody have a great rest of the conference. Thank you very much.
Thank you.
Thank you very much, Peter.
Hello, everyone. Hi, everyone. How are you doing? I am going to be around after this presentation right now to answer any questions. So if there's any questions, please feel free to pitch them on the chat bar or go ahead and shoot away. Okay, first one. How does policy and regulation variables across the country impact the rate of advancements made in desalination? That's a good question. I'll take a stab at that, and I want to preface it too. If there's anything else that you have related to Gil and Michelle's topic, to please reach out to them separately. But in general, without regulation and policy, people can basically, it's an open market. The policy and regulation drives this business of desalination, and as water becomes more and more, less and less water to pump, especially with desalination, then we're going to have to change our thought. And this is going to drive technology advancement across the disciplines. And you're seeing that nowadays, in especially what we talked about in this presentation. Next question. Can you talk about how to integrate these new innovations in the current desal systems? I can talk about our project, the Pitch to Pilot, and what we're doing is we're using electrocoagulation, which is an alternative to chemical coagulation. We're not adding a metal salt. You're actually forcing a DC current across a salt bridge, which is the salt water, and you passivate the anode, and you get the iron in the solution. And then what that does, there's about 6 different unit processes, but it does a very efficient job at removing the divalents, which otherwise would scale your membranes, and silica and phosphates. And anything biological that is in the water, when you pass electricity through the water, it cavitates the cell wall. So you get a destruction and a kill with that. So if you have like red algae in the water, it will address that. And then all you have to do is precipitate it out, settle it out with a looser membrane system, like either UF, NF, MF system, and then send basically just sodium chloride to the RO system so that you can get a higher throughput of the RO and come out with a lower flow rate of concentrate, but a much more concentrated concentrate, if that makes any sense. Pardon me. And then also, once you have the higher concentrate, you can go ahead and flash that and get rid of that with some thermal. The vacuum assisted electric distillation system does a good job at lower energy intensity. And we're going to also take the brine out of that VAD system and use it for on-site sodium hypochlorite generation to be used in the cooling tower. And what gets you excited about the USBR project you're working on? Well, I think it's really pushing the envelope of technology, and it's actually one good thing about it is it's not quite the first time it's been done. It's been used before in the past. In fact, Dr. Mike Mickley studied it extensively for the Office of Naval Research using EC as a pretreatment to membrane systems. And we learned a lot from that project, and we're going to use his lessons learned integrated in this project and see how we can try to fine-tune it a bit. Ultimately, we're going to try to break whatever we're trying to research, because that's the whole purpose of us researching it, is let's see what breaks it, and if it doesn't break, then let's move forward with it. So I would say that's really innovative, and the concentrate management portion of it is a new technology. It's still it's a very low technology readiness level, and we are ready to get moving on that. So yeah, look forward to presenting a lot of this in the future. Hopefully next year we'll have some more stuff more results to present. Next question, can you sum up what you'd like listeners to take away from the desalination discussion? I would say that the biggest takeaway from here is, technology can make huge advancements by just optimizing some of the unit processes, feeding the RO system, and then also taking care of what comes off as concentrate. So RO systems have been around for a long time. They're actually pretty robust and efficient. It's just how clean can we get that water feeding the system, and then push the recovery. And then ultimately, what comes out one end, hopefully, if we can use this, kind of look at treatment as a resource recovery. Basically, what we're trying to do is take this brine that has no calcium in it, which is pure sodium chloride by the time we take it out of the VAD system, which should be a feedstock for another industry, and try to create a circular economy. So let's not look at brine as trash, but let's look at that as a treasure. Okay. I think I'm okay. Tamara wants to join. Okay. All right. Yeah. So another thing too important when you're researching new technologies is let's not just look at the recovery and how clean the water gets. Let's look at the energy intensity of that unit process. It's very important. And if there's any questions on my end, feel free to give me an email or call. My email is ejdole@Garver, GARVER, USA.com, or you can just reach out to me on Hula Hoova app. And is it? Okay. Do you want me to do the intro to the break? Because I think they're doing the break now. All right. Okay. And with that, we had a little bit of technical difficulty getting Tamara on the call, but I'm going to hand it off and say next is the break. So I think there's a few minutes here for everybody to take a break and go get some coffee or a drink and come back and reconvene in about 10 or 15 minutes. All right. Thank you very much. And I appreciate the opportunity.
Hi, welcome back from the break. We're thrilled to have another set of wonderful, collaborative, innovative thinkers here to continue the water and wastewater track. Take it away, Jamie. Thank you.
Hi, everybody, and thanks for joining us today. This is the Water Energy Nexus panel. So yeah, thank you all for being here. We have a great panel ahead. And yeah, if you could start my slide deck, I'll get right into it. I'll introduce myself first. I'll introduce the panel and a little bit about the company that I work for and how we engage in that water energy nexus. And then I'll introduce the panelists and we'll go from there. So again, my name is Jamie Garrett, and thank you for joining today. I work for a company called NG. If you can go to the next slide, please. And first, I just wanted to kind of provide some context for this discussion today, for this panel. So we're talking about we're in the water and wastewater track, and we're in the Water Energy Nexus panel. And we just wanted to, first of all, give context around how water and energy are interrelated and interdependent. Basically, in order to produce energy anywhere, water is just a huge part of that. This is just a graphic I found from energy.gov a while back, but it's still relevant today, and it probably will be for forever. In order to produce energy, water is used to keep things cool. It's used to help to extract energy out of the earth. And what we'll be focusing on more today, though, is how energy is used for water, for treating and transporting water to make sure that it's safe for us to drink and to use, and for cleaning ourselves and cleaning for just using in our daily lives. But then also how energy is used to clean water to give it back into the water system so that it's safe for wastewater too. And I forgot what the percentage is, but I think the majority of energy used in is actually for water treating and transportation, for pumping and treating water. So we'll get into that. And if you can go to the next slide, the basis of this conversation is that really when designing a project for any customer, it's important to really consider water and energy. You can't just do you shouldn't just do an energy project or a water project. It wouldn't be maybe the most holistic, well thought out project unless they were kind of thought of as an interrelated pair in that nexus. That would give the best benefit to the customer. If you can go to the next slide, please. So there's some barriers that kind of prevent projects from moving forward, any project, but especially related to water and energy. I just wanted to give some context on what makes a project go. So there's three things that need to kind of work together in order to really have a successful project. So the policy, the technology, and the economics. So both of water and energy have been important forever, and they always will be, but the technologies and the business models that are needed to make a project go are constantly, it's very dynamic, right? Things are always changing. And so policy needs to keep up with those technology advances and incentivize those things so that they can align with market needs, so that customers, whether it's public or private sector, have access to those things and are able to utilize those technologies the best way that they can. And speaking of technology, any program is going to be most successful if, again, it kind of looks at the water and the energy portion of those projects and looks at the efficiency, renewables, and resiliency related to both energy and water when selecting technologies. And one of the reasons, and this is one of the things that NG does really well, is that when things are bundled like that, faster payback technologies can help to pay for those slower ones in one project. So like LED lighting, for instance, if that's part of a project, a retrofit project for a public or a private sector customer, those savings are so fast and so big from that LED lighting that you might be able to bundle in a water saving technology for them as well and have the savings from that energy from the LED lighting project pay for that. So combining those technologies is going to enhance one another. And finally, the economics or the business model behind it. So again, sometimes the water does have a lot of savings, but it might not be as quantifiable as those energy savings. So that's why it's important to bundle those together and combine all available funding sources, and then making sure that there's a variety of contracting structures available to be able to offer to the public or private sector that are going to work within their resources and constraint and allow them to implement that water energy project. Next slide, please. So in order to stay on time, I'll just give a brief summary of ENGIE. We're a worldwide company. We work in the renewable energy space all over the world. I'm in the Cities and Communities division. I'm out of San Diego, California, and we work with the public sector primarily, and we help them to achieve environmental, economic, and community impact goals by doing design, build, energy conservation programs and water conservation programs. So for cities, school districts, water districts, entities like that. And next slide. And we work with partners in order to accomplish our customers' goals and get these projects to fruition. And so I'm really happy to introduce our panel today. They're all companies that we would potentially work with on a project, and all of them are doing amazing things in this water energy nexus space. So first we'll hear from Stephen Conger from P4P Energy, who has a PV panel suspension system that's really unique and allows you to build solar over water, which is amazing. And then we'll hear from George Diefenthal, who's with Neotech Aqua, who has an efficient and renewable UV technology that he's excited to tell you about. And then Carlos Gaitan from Benchmark Labs, who helps you kind of see into the future and predict what's going to happen so that you can plan the project properly using the best data available, especially from weather predictions. And then Will Sarney from the Water Foundry, who helps more on a consulting basis, providing business strategy, technology, and investment for water energy projects. And he's been doing it for some time. He's a wealth of knowledge. So without any further delay, let's go ahead and introduce Stephen to talk about his technology. Thank you.
Okay, well, let's go right to the slideshow because I want to finish on time as well. So thank you. I'm Stephen Conger from P4P Energy. And is the slideshow up? Okay. This is a project that we built. We built two 2.5 megawatt solar projects in Punjab about 3 years ago. We built 1.6 miles of canal cover in 10 weeks. We were supposed to have 6 months, but it took 10 weeks. This is an east-west canal, so you see a big plane tilted south. Next slide, please. On the top slide here, you see the other 2.5 megawatt project, which was on a north-south canal, and you can see we can adjust the angle to face due south. On the lower image there, you see a conceptual project we did that for the state of Gujarat in India. We presented this to Prime Minister Modi when he was the chief minister of the Gujarat. And this is a 365-foot wide canal that connects the Saraval Dam, which is the main water supplier for the Gujarat, to the capital city of Ahmedabad, 130 kilometers away. The 130 kilometers would be about an 8 gigawatt project, and the dam has reversing turbines that could actually be a base load. Next slide, please. Next slide. One of the major advantages of the P4P is we use significantly less steel than other systems. In this case, we used 110 metric tons of steel per megawatt in the Punjab project, and there was another project built nearby that used 265 metric tons of steel per megawatt, so about 40% of the steel required. Next slide, please. I'm going because I want to get to the end. Okay, we have 50 patents that for cable structures supporting solar. Next slide, please. Our cable structures are especially well suited for doing multiple use systems. We can span over agriculture, parking, roads, canals, and these multiple benefit projects can optimize the value of the whole system. You see an over road and over an early version of our over agriculture system. Next slide, please. The California State Water Project and the Central Valley Project are the largest water system in the world when combined. And when the water is pumped over the Tehachapi Mountains with a 1 million horsepower pump into Los Angeles, it's the largest energy user in California, using about 5 terawatt hours of electricity annually. And it's estimated from a study we read that 3.4 million acre feet evaporate from the canals annually. Next slide. Next slide, please. This shows a system, oh, sorry, back one, excuse me. This shows a system over the California State Water Project. And you can see a yellow pointing to a bottom cable where we can suspend a membrane. We have a patent on covering the canal with a membrane suspended on this bottom cable, which can actually also act as a reflector to increase the value of the solar above with bifacial panels. Stacking values. Next slide, please. There was a study done in 2015 at Cal Davis, and the goal of the research was to provide a cost-benefit analysis of the implementation of evaporation reducing mechanism for the California State Water Project. Next slide, please. So we did a back of the napkin analysis of this, and this is, I state this is only a back of the napkin analysis. Our system would cost to put it over the canal about $20 billion, and that would be about $1.15 billion in payments a year over 25 years, with an overall project cost of $28 billion. If you value the water and energy over the 25 years at $390 per acre foot, you get $105 billion in total value. At $190 per acre foot, you get about $88 billion in total value. And the conclusion of the study was that as we move forward in the face of ecological devastation, economics can no longer be the only factor that is considered when implementing infrastructure reforms. As this back of the napkin analysis shows, perhaps it's not necessary to sacrifice the economics to increase the water and efficiency of these canals. Okay, thank you. Hope I did it in time here.
Thank you, Stephen. Yeah.
Can you hear me? Everything went, sound went away. Can you hear me out there?
I can't hear you. The rest.
Okay, I'm back. My sound went away for a minute.
Yeah, mine too.
Okay, if you want to pop up my slide deck, I will get through that. All right, thank you everybody for joining us. I'm George Diefenthal, Neotech Aqua Solutions. We make very efficient UV systems. Next slide, please. A couple comments on the water infrastructure as it is now. There's a lot of inefficiencies built in as we centralize all of our treatment facilities, and we have these silos of different water treatment areas that over time, hopefully we will address those and make use of all the technologies and processes available. And I think policy needs to address these issues. Next slide, please. We could design smaller, more decentralized systems, reduce chemical requirements, focus on water reuse, lower pumping costs, which is, as was just mentioned, is one of the major costs in all of water treatment, and potential power from renewable resources, which we also just saw. And just to focus on these technologies that you will see with us as well as others today can really benefit the whole infrastructure that's available. or will be rebuilt. Next slide, please. So our technology, we manufacture a UV system, and with the technology and our patented systems, we have generally 1/3 the size of conventional UV, using 75% less energy and 80% fewer bulbs, which is the lowest operating cost available on the market today. Next slide, please. And the way we accomplish this is we use the lamp and sleeve in the middle like everybody else, but then we have a larger quartz tube, and then around that quartz tube we have a reflective material, and then a more stable structure on the outside. And the result of this, next slide please. If you look at conventional UV with a stainless steel treatment chamber, the stainless steel will absorb 80% of the UV that impinges on it. Next slide please. So that, and the next one, and the next one. So you'll see that it takes quite a lot of energy to reach the little red dot that you have in there, which is your bacteria that you're trying to disinfect. With the reflective technology as we have it, next slide please, the UV light bounces around inside the chamber until it strikes the required pathogen, so we can be much more efficient in using the light that's available. Next slide, please. So basically what we've done is we are using the same lamp technology as everybody else out there in the market. We're just using the light coming off of it more efficiently than everyone else, which is the basis of our patents. And as an example of how we're doing this, we've been working with partners to create systems that can treat cooling towers. And with these cooling towers, we have a couple in use right now. They've been in use for almost 3 and 4 years at 2 facilities, and they have been running chemical free for this entire time, which means that when you do have a blowdown event, there's no chemicals that the wastewater plant suddenly has to deal with. Secondly, and the chemicals that you're dealing with are both from a disinfection as well as a scaling issue, and that eliminating those saves an incredible amount of money, and we see payback generally in less than 18 months. We also reduce the number of blowdowns. The one system that is in constant use has a blowdown approximately once a month instead of a couple of times a day, and the second system has not had any blowdowns in over 4 years, but mostly because they don't operate 7/24. They shut down in the evenings and on weekends, which allows the system to catch up and keep the TDS down. The big thing I think that is important to note here is that on chemicals and energy, it's easy to see and measure what the savings are. And water usage is much less so because you don't meter these individual sites. So it's difficult to actually get numbers for that. And it's also difficult to get input from the utility to provide bonuses or payback credits, whatever, for lowering the use of water and or from the wastewater plants to get the same type of benefit. Energy companies, utility companies will provide a fee structure or a payback structure that will help on that. But the water utilities, and whether they be drinking water or wastewater, have not done that at this time. So moving forward on that, I think will really push this whole energy water nexus forward. And with that, I hope we're getting back to closer on time. Thank you.
Thank you, George. And with that, we'll move on to Carlos's presentation.
Thank you. Let's start the slides, please. Let's start the slides, please. Perfect. Okay, so thank you very much for the invitation. I'm very happy to be talking here at the Water Energy Nexus panel. My name is Carlos Gaitan, and we at Benchmark Labs do environmental forecasting for the ag, energy, and insurance sectors mainly. Next slide, please. What we want to do, and our mission, anyways, is to provide better weather forecast for any place that has an IoT device. It could be a soil moisture sensor, could be a thermometer, could be an anemometer, solar installation, a wind farm. And what we achieved here is a forecasting system that provides the forecast for that specific location, not for average conditions over a big area. Next slide, please. So the problem in many ways that we found is that in agriculture, in energy, insurance, they all share a problem called the spatial basis risk. And it's basically, it occurs because the weather models divide the world in grids, in boxes. And but in reality, the users are inside of those boxes. Usually those boxes can vary greatly in scale and be several miles by side. While farms, where you care about your irrigation management schedule, where you have like your wind farm, your solar installations, they occur at subgrid scales. Therefore, there is an inaccuracy of the weather forecast on what is happening in your farm. That means that the farmers, the energy operators are unhappy because they are receiving data that is necessarily not representative of their in-field conditions. And of course, those inaccuracies lead to forecasting errors that, for example, could be catastrophic at the farm level if you fail to predict a frost event or a heat spike that can affect, for example, your labor scheduling because of OSHA regulations. As an example, you cannot have people on the field working if the temperatures are above 100 Fahrenheit. And traditional weather models are particularly not accurate when dealing with these extremes. So next slide, please. So our solution, it's in many ways, we try to tackle this problem in a very alternative way. So we said, forget about the divide the world in grids. Let's try to do something for the specific user. You don't care about what is happening at your county level, at the country level, at the continental level. You care what is happening at your farm. So what we do, have like a patent pending technology, is we integrate the best of both worlds, basically IoT sensors in field, and the global forecasting system from NOAA, the National Weather Service, satellite data that can provide that information. And we just refine it using a neural network. We provide a specific forecast for each environmental variable that the IoT sensors provide. And then that leads to in-field accurate forecast. Next slide, please. As an idea of what you can achieve by using these kind of technologies, when you compare the gridded forecast error, and that is coming from the National Weather Service, and what our users were getting in terms of forecasting mean temperature, that is very important, as we were mentioning before, for frost forecasting, for heat labor, for growing degree days in agriculture, so you can know when phenological stages are reached. We reach a 35 reduction in terms of the errors relative to the GFS. That is what NOAA provides. And that's only for in terms of temperature. We had done the same analysis for relative humidity. The increments in accuracy was like 50%. Wind forecasts are particularly inaccurate at the gridded level, and we can also perform that. So these relative error improvements at the end propagate on the value chain, and that leads to financial benefits for farmers and energy users. Next slide, please. As a specific case, I wanted to show you crop evapotranspiration In this case, you have a personalized forecast that we provide in Benchmark. We integrated with NDVI, that is a vegetation index, to provide a crop coefficient specific index at your location. And that leads us to provide a specific ET, or like evapotranspiration, at your crop level. So not a gridded area. This evapotranspiration at the end is related to water use, to energy use, because most of our users have to pump the water, and that's has a significant amount of energy that needs to be involved in the activity, and then they can schedule their irrigation more effectively. Next slide, please. Then this is an interesting application we are doing with NASA. Forest Fire Index Forecast is important for SDG&E, PG&E. We know that energy operators care a lot about forest fires, especially with Santa Ana winds here in San Diego. We have an ability to forecast up to 6 months in advance fire index. And that's also one of our applications. Next slide. And I just wanted to end by thanking to NASA for their support, TMA, NOAA for being a water-ready nation ambassador company, and our supporters, the Southern California Energy Innovation Network, and our investors. Thank you very much. That's all.
Thank you so much, Carlos. And finally, we'll go over to Will. You could pull up his presentation, and then we'll move over to some Q&A panel discussion. Thank you.
Okay, good to go. So first, thanks for the opportunity to be on the panel and have a lively discussion. We're a little bit different, or maybe a lot different. We are a consulting firm. We've got over 20 years of experience in providing sustainability and water strategy services to multinationals and technology startups. So I'll give you an overview of where we fit in the world of water, our point of view on strategy, water strategy, nexus issues, and probably most importantly, innovation and what's going on. So next slide, please. So this is where we fit in the water ecosystem. So the upper left, US, non-US multinationals, really across a range of industry sectors. What we've seen through the years is that the CPG, food and beverage sector, has been leading on water strategy because water is a key input, and they're very focused on managing risk, but also using water as a way to drive business growth. So you see, the most recognized brands here, but also in some other industry sectors, including information communication technology, heavy manufacturing in the auto sector, and also extractive industries. We also do quite a bit of work on the right here with technology startups and water technology innovation hubs, platforms, and prize competitions. So a number of the companies that we work with are in the upper right. Most of them are in really two major categories. One is with respect to digital technologies, really leveraging digital technologies, which we heard a little bit about before, to improve resource efficiency and use, whether it's water and ag or water as a standalone issue. And then also alternative hydration, real-time water quality monitoring, things like that. And then in terms of the hubs, accelerators, prize competitions, a lot of really interesting things going on with these programs to really identify and accelerate innovation in the water sector, but also related to water as a critical nexus issue. And then in the lower left, we do work with NGOs such as WWF, FEMSA Foundation, Inter-American Development Bank, and others. And collectively, this gives us a broad view of what's going on with water and how water intersects with the other sustainable development goals and drives economic development, business growth, ecosystem health, and social well-being. Next slide, please. For us, we talk quite a bit about water as a wicked problem, and we're not implying it's wicked unless you don't have access to it, and then it's certainly that. But wicked problems are complex. They have a definition definitely worth looking at. And one of the key attributes of wicked problems is that no one stakeholder can solve wicked problems. And we embrace that because, as you saw previously, we really engage with a range of stakeholders that really are required to solve water, wicked water problems. And in the upper left, we've got entrepreneurs. Their attributes are that they have speed and focus, but they really don't have much scale, unfortunately. Lower right, we've got the public sector that has size and scale, but is slow compared to the other stakeholder groups. And then in between, you've got investors that are, closer to the entrepreneurs, but then the private sector and NGOs, it's somewhere in the middle, and depending on who they are and what they do and culture and so on, they would be either closer to the public sector or the entrepreneurs and investors. And it's really important to engage a number of these, actually all of them, in terms of solving complex water and nexus issues. And I'll touch on that in a few minutes. So next slide, please. I mentioned earlier that on the innovation side, and then also with multinationals in terms of how they manage water-related risk and social license to operate, we focus on digital technologies. The digital transformation of the water sector is, in our view, the most transformative and enables technologies such as localized, decentralized water treatment, democratizing access to real-time data, obviously, and some other trends in the water space. So the way to think about digital technologies is really across the value chain. So for a utility or for a private sector client, whether it's food, beverage, or manufacturing, upstream they've got their supply chain. So if you are a food and beverage company, you have a critical ag supply chain that needs water and it needs energy. So how do you use digital technologies to ensure that the supply chain is sustainable and resilient? And then all of these companies have a supply chain, obviously, within a watershed. They operate within a watershed. So again, how do you use digital technologies to understand what's going on in the watershed on a real-time basis, as opposed to waiting for data to come in from the field and it's analyzed and so on. Incredibly powerful. A couple of companies that are in the space right now: Jive, real-time water quality monitoring using satellite data; Cloud Discrete, again, using satellite data and analytics for flood prediction. And then you've got what's going on in the four walls, so to speak, whether you're a utility or a manufacturing plant. And we're seeing a lot of interest and action that really was started prior to the pandemic, which has only been accelerated. So you have companies like Intellecy that work for the utility sector, using satellite data and analytics to identify leaks and system disruption. And then you've got Kando that also works in the wastewater utility sector. Again, advanced analytics to understand water quality, system failure. And then Pluto Shift, an AI company that works in both the industrial and utility sector with AI solutions to not just manage resources better, such as energy, water, but also identify treatment membrane performance. Then you've got engagement with customers, and a number of digital technology companies are working with utilities in particular to better engage them in a two-way conversation about water use, availability, issues like lead line replacement, but also companies that are moving into real-time water quality monitoring at the tap to give consumers an immediate understanding of whether the water that they're drinking is in fact safe. Next slide, please. So just a little bit more about where we fit and who we work with and what we do. AB InBev is a really interesting example of a company that is certainly engaged in water stewardship in a very traditional way, but also driving towards a robust water strategy, which means that they are investing in innovative technologies and nurturing those technologies through their 100+ accelerator. And a number of companies have come out of that accelerator and are doing well, not just with respect to water, but startups that are tackling climate change, renewable energy issues, agriculture, engaging with smallholder farmers through blockchain solutions. And then where we find, I would say, the most action and impact is with exponential technologies. And what we see is companies like Jive, again, where they're using satellite data, Pluto Shift, artificial intelligence, but also Spout, real-time water quality monitoring at the tap, and Sierra Helix, which is engaged in advanced treatment membrane technologies. Next slide. So thank you for the time. I look forward to the Q&A.
All right, thank you, Will, and thank you, everybody, for giving a presentation on who you are and the great work that your companies are doing. You all spoke about technologies and business models, data, digital technology, policy that's really adapting quickly and changing constantly. How specifically does your company address these things, either one or many of those items I just said, to specifically mitigate risk for either public or private sector customers, and help to mitigate risk that helps to maybe avoid cost or provide more quantifiable savings that will help to avoid some of that perceived risk? And how do you think that will help to move projects forward into the future? And we'll start with Will. We'll maybe go in the reverse order of the presentations. Yeah, so how does your business help to address that risk and make things better into the future?
Sure. So sort of the obvious examples which I laid out are, water is a critical input for food and beverage companies, but, apparel companies also, and heavy manufacturing and so on, automotive, semiconductor manufacturing. So helping companies understand not just water risk from, okay, I've got a manufacturing operation here, I've got my supply chain here, and water is stressed and scarce, but translating that into business value at risk. So translating it to $1, a euro, or other currency, so companies can make a more informed business decision that goes beyond the current price of water or full cost of water. So that's the starting point. And then, once you can quantify business value at risk, both tangible in terms of business continuity, but also brand value, then you can start to engage them in a conversation of, okay, so, what do you do about innovation? And that includes certainly things like technologies. So, driving water efficiency and reuse, engaging with their ag supply chain, but also helping them understand that they have a different role to play beyond just their water risk, and they can actually participate in making investments, and are good examples of that. Microsoft, launching $1 billion climate fund. Water is going to be part of that. Ecolab and Microsoft launching a $100 million water technology venture fund. And then, I mentioned AB InBev and what they're doing with the 100+ accelerators. So, there's the water risk piece of the puzzle, limits operational continuity and business growth. And then there's the, okay, how do they really participate?
Yeah, it's almost like instead of being reactive and saving money, what's the proactive, what's the opportunity that they could see through savings? That's really interesting. Carlos, we'll give you a chance to answer the same question.
Thank you. I will take 10 seconds. So from our perspective, we help them to mitigate risk by providing forecasts. So they, in terms of agriculture, they can see if a frost spell is coming, they can activate some measures at the farm level, like to raise the temperature. If the opposite is happening, like a heat wave, heat spell, they can schedule labor later. So when they don't have to deal with those inefficiencies and so on, we can. Thank you.
Yeah, you almost help them to see the future, I guess.
Mm-hmm.
And I think we still have 5 minutes, so we'll continue unless we get told otherwise. So go ahead, George.
Hi, yeah, thanks. I think from a equipment standpoint, the use of UV can seriously reduce the reliance on chemicals for water treatment. And the use of chemicals is almost like a whack-a-mole thing. You fix one problem and these other three prop up. Kind of like the move towards chloramines got you away from the disinfection byproducts, but now chloramines generate different disinfection byproducts, which may be worse. That's to be defined. But it also generates a little bit of nitric acid. So if you have copper plumbing, it starts eating into that. And it also, the nitrogen results in algal blooms downstream. So there's all these types of things going on. But the other part of this is that, as Will mentioned, the public sector is much slower and less desire or less will move towards new technology much slower than industry will. So I think the way to attack this problem is to let industries innovate in their water practices, which will take some of the burden off the utilities as you do more water reuse and you're more efficient in your water use. Those are all benefits that I think will help the utilities lower their demand for new facilities and all of that kind of stuff. But on the same side, the private sector will, even though you can wave the green flag, which is nice and all that, unless there is a financial benefit to it, it won't happen. So the technologies and the efforts that show up have to show an economic benefit for the private sector. And as those technologies come into use, I think the public sector will follow, despite their claims of, we want to be innovative. They just are not able to do that as well as the private sector can.
That makes a lot of sense. And it looks like we have an audience question. So Stephen, and we don't have much time. So Stephen, I'll let you take your pick between answering that question. And I don't know if you could see it at the bottom. What is the biggest challenge your company or organization face?
I think I'll do the risk one. One of the biggest risks is lack of water and the instability of water. And like I heard this year that the agriculture is getting about 10% of what they could in California. So by eliminating evaporation, you maintain whatever water you have as a base, and so that could mitigate risk. And the solar part of it is pretty understandable, but the water interaction is not so far. That's a quick one. And our biggest challenge in the company right now is scaling fast enough to make a big enough difference in these challenges.
All right. Oh, go ahead.
Yeah.
Okay. So we're almost at time. So thank you everybody for joining and for listening. You're welcome to follow up with any of us after. We can answer the question that we didn't get to about our biggest challenges or any other questions you might have. I believe the contact information was provided to you in the registration, or you can find us on the app. So yeah, thank you all so much. Thanks to all the panelists as well.
Thank you.
John, we can't hear you.
So I'm Rick Bacon, Chief Executive of Aquametrology Systems.
All right, how about now? Great. Well, it wouldn't be a virtual conference without that. So, hi everyone, welcome to the panel, Big Data, Big Value, Bigger Fun. Thank you very much to TMA Blue Tech for inviting us. It's been a great conference so far. And yes, I am walking on a treadmill. The main reason for that is we aren't in person, and I wanted to ensure that everyone feels welcome. Since I know a bunch of the drinking water and wastewater folks, what better way to welcome the ocean folks than by making everyone seasick? We've got 4 outstanding panelists today to provide their diverse perspectives on the subject. I'll introduce each, they'll present, and at the end, I have some questions, and we hope to get some from the audience as well. Before I introduce our first panelist, we were going to do a small data, small value survey and ask each panelist what they were wearing, shorts or pants. Rather than do that, I'll just say I'm wearing shorts, and it's their prerogative to let you know. Up first, we have Rick Bacon. Rick has been the CEO of AMS since 2012. AMS develops and commercializes online, real-time analytical and remediation solutions to predict, control, and treat regulated contaminants in drinking water, processed water, and wastewater. He's held a variety of roles in senior management or board positions in the energy and water sector. He holds a degree from UC Santa Barbara and an MA from Cambridge. And I'll pass it over to Rick.
Thanks, John. I'm wearing something, so you'll be pleased to know. Okay, so I'm going to talk about water quality data. Aquametrology Systems is based in Silicon Valley, and our roots lie in monitoring water, processed water for the semiconductor industry. We've moved on that in the last 10, 15 years. Next slide, please. So our roots lie in analytics. So we do a range of water contaminants ranging from methanes all the way through to trace metals. And more recently, we patented a unique treatment system, wide range of waterborne and airborne contaminants. And those treatment systems integrate with the monitoring, provide an intelligent water treatment system that can be fully automated and remotely controlled. Next slide, please. Can you click? So I really want to talk about the quality of water quality data. So if you could click through this, please. So there's data and there's data. And the most, and these are the criteria that I think we should think about when we're talking about data. It's not just a sort of an amorphous lump. Firstly, that data needs to be timely. Why is that important? Because you as a consumer will get your water quality report 3 months after someone in your city drunk that water. And that's not very timely information for you when it comes to making intelligent decisions about whether to drink the water or not. So timeliness of data, very important. And accuracy and precision. are the two factors, parameters that will tell you whether you can trust that data. Is it accurate? Possibly, but is it precise, meaning is that same data going to be generated time after time? Availability, so you can have instruments that have been tried and tested in the lab, and they may be accurate and precise in the lab, but then when it comes to the real world, which is not always nice, clean water, but can be heavily contaminated, will that instrument, will that data still be reliable? And availability, it's no good having whatever instrumentation you're using if that instrumentation isn't working. So one of the criteria for this sort of big data set is that it is available on an ongoing basis and not just when the machine happens to be working. And then finally, is the data meaningful? So if water contamination is changing on a frequent basis, but only get a reading once every 24 hours is not going to be helpful. That data will not be very valuable. There's a big issue around the representativeness of data. Many times we'll use proxy indicators for a contaminant concern. People use TOC or UV as indicators of something. It may be representative, but we need to understand whether it truly is. Predictive data can be extremely valuable. A reading taken today of a contaminant that is changing in a distribution system is not going to be very helpful. But if you can predict what that contamination level will be accurately and precisely later 300 miles away in the distribution network, that's clearly much more valuable data. And finally, is it verified? Too often, whether it's a US election or water quality, many times data is produced that is actually verified and therefore about its quality and usefulness. So now, having put the data and its quality in context, I'll talk about some of the value applications of water quality data. We can move to the next slide, please. So the first use of data is for characterization. The value here lies in being able to design a system is for purpose. Too often infrequent data is used, usually laboratory-based sampling data, that does not reflect what goes on in a typical water treatment system. Many times investments are undertaken before an effort has been made to understand how a treatment system can be modified and changed without substantial capital investment. So real-time data will provide that opportunity to carry out those sort of simulations. Vendors will make lots of promises about how well their system performs, but without extensive evaluation of those systems in the field with high data, it's very different whether they're actually going to perform as promised. The big value opportunity is written around process control, whether that's blended treatment, and finally it's the canary in the mine that will alert consumers, asset owners, the community at large, as to whether there's a regulatory breach or a breakdown in treatment that puts the environment at risk. So those are the 6 buckets of value from having high density real-time quality data.
Awesome, and thank you, Rick. Next up, we have Tim Southern. Tim founded Aramosa, a consulting engineering firm 20 years ago. His most recent title is Chief Innovation Officer and Chair of the Board, while his most impressive title, if you've gotten a business card from him, is Master of Chaos. Aramosa has developed 2 spin-out technologies, Iris, which was acquired this summer, and Hydrant AI, which provides holistic network monitoring. He holds degrees from Queen's University and Guelph University. Tim, over to you.
Thanks very much, John. I appreciate the opportunity to speak today. Next slide, please. What we're featuring, and in general today, is a huge data inundation. And where we're trying to go with this, and to Rick's point about good, reliable data, is to find information clarity. So take our data, turn it into information, and eventually gain knowledge about our network system. So here we're thinking particularly about the water distribution system. Next slide, please. As part of the data we have available, we have an immense amount of utility data that is typically stored in a number of different locations within the utility, such as their SCADA system or process control system, their GIS, their CMMS, their models, their AMI or CIS or billing systems. All of this data is available for us to work from in achieving value. Next slide, please. Our customers also have a significant amount of data. Typically, our customers' data becomes utility data over time. So from the utility perspective, we may have an AMI system, we may have a customer information system. Our customers reach out to us by phone or by email, and ultimately we log that information back into the CIS system. Being able to use all of this information together with our utility information and our data sets allows us to learn more about the network monitoring and what is happening underground out in the distribution system. Next slide, please. If we then consider smart utilities and smart cities, and we start looking at field and IoT data, what we start to look for are things like pressures and transients, flow, bidirectional in and out of DMAs, acoustic data, water quality data, temperature, air, rainfall, sewer monitoring. So we start to collect an immense amount of data from devices in the field. How we do this is from things like instrumentation, segmenting our network into metering areas, looking at sampling and recording data from there, finding open data sources that can feed information in that help us understand our network better. Also, we start looking to IoT applications, and there are a number of them in the marketplace today that provide hardware and software solutions for network monitoring. We also need to find access points into our network in order to be able to collect that data. Next slide, please. So we need to ask ourselves, what problems are we trying to solve? Is it about energy consumption? Is it about managing our assets underground? Is it a leakage question, customer satisfaction? Are we trying to manage our pressure in our distribution system? Are we looking to achieve better water quality? Or are we looking to transform to a digital utility? Next slide, please. As part of this, as we look to move forward and understand our network better, we also need to start formulating the right questions. If cost were no issue is a great leading example of how we need to ask those questions. It might spur us to think of solutions that are greater than what we might think of if we were cost constrained. Also, is this about pressure? Is this about life cycle of the assets? What data are we going to need in order to answer the questions that we have? Next slide, please. As John mentioned, one of the spin-offs we've been involved in is Digital Water Solutions, which has this product called Hydrant AI. So Hydrant AI provides the monitoring of water temperature, pressure, transients, and acoustic leaks in the distribution system. We use the access point of a fire hydrant for this. And then we also can use utility data and open data and other IoT data platforms through our APIs to bring information together. Next slide, please. What this does is create a platform that we can use to do analytics on the data from the distribution network. Using this platform is just one way you can get greater value out of your data, as there are several platforms on the market that can integrate data from different sources. Next slide, please. Quickly walking through how our solution works. There is an analytics component that is tracking noise within the water column. So we're actually situated in the water column looking for break and leak conditions. As you can see here, there is a pre-existing leak that's occurring within the system prior to a break condition. Following repair, the acoustics return to their normal baseline. This is one quick analytical example of using water noise in the water column. Next slide, please. The interface gives quick graphical representation to users as to the noise characteristics and the area in which a leak or a break has occurred. In this example, you can see that a number of the monitors have lit up, and you can see the different type of noise profiles that are being received from the different monitoring points. Next slide, please. When we consider how small a leak we can detect with this kind of technology, and as you know, it's getting better each day in terms of what we can detect and how low a flow we can detect. This is a swimming pool example, so about a 5 to 6 gallon per minute flow rate. 20 to 25 liters a second in Canadian metric. Next slide, please. The analytics also allow us to determine where leaks have occurred and continue to occur. This is an example of a leak running underground to a catch basin. So being able to run analytics to track the overnight sound in the water column allows us to quickly deploy people to fix the issue. Next slide, please. Of course, we can use pressure together with acoustics to identify where a problem is being generated within the system. Here we see the leak pressure is about 8 pounds less than the actual normal operating pressure, and we can see that the noise is running about 6 decibels higher than normal. Next slide, please. Ultimately, in a day, we have to be able to combine our utility data, our customer data, our field and IoT data in order to get a better understanding of what's happening in the network. However, going forward, we will also start to integrate things like social media, where we're using customer and crowdsourced information to help us find and detect leaks within the distribution system. Thanks very much. Back to you, John.
Awesome. Thanks, Tim. Next up, we have Erin Rothman. So Erin is the CEO and founder of Storm Sensor. She founded Storm Sensor with the objective of managing climate risk through creating intelligent stormwater, sewer, and coastal infrastructure. She has over 15 years of stormwater and remediation experience across the US, and she holds degrees from Ohio, which is where I grew up and went to school, from Miami University and The Ohio State University. Erin, over to you.
Thank you. So as John said, my name is Erin. I'm the CEO and founder of Storm Sensor. We are a climate tech startup focused on water, and we work with cities and consultants across the United States to track how water moves through their storm, sewer, and coastal infrastructure. So I'll just review what we do and cover 3 very short case studies. Next slide, please. So we focus on capturing data via dense sensor networks, basically metering the last unmetered utility. Our network sensors capture accurate temperature, flow, and weather data every 5 minutes, every day. And then our software delivers simple, practical insights that give communities the information that they need, to manage the risks they face from flooding, tidal surges, and overflows. Cities use this data to streamline their operations, receive real-time system diagnostics, and then also guide future investments and capital improvements based on trends. We provide real-time system notifications for proactive and emergency response planning, and we're also working with our customers to develop new coastal and surface water features that include tidal flow separations, backflow or tailwater notifications, and then statistical storm events analyses. Next slide, please. So while the possible uses are endless, we focus primarily on 3 key use cases with our customers. So the first is flood control, looking at urban flooding, sea level or water level rise, storm surge, and then surface water flooding from rivers and lakes. We also do a lot of work in critical infrastructure and maintenance because the bulk of our sewer and stormwater infrastructure often exceeds its useful age as well as the capacity that it was built to handle. And then we do quite a bit of stormwater model validation because so much of our infrastructure is failing or changing as a result of climate change. Many cities are reevaluating their hydrologic and hydraulic models. Next slide, please. As far as value add, if we're looking at anticipated return on a city's investment, if they deploy Storm Sensor and if they take action based on the insights that we provide, the benefit for use cases from O&M to flooding range from about 4 to 12 times the amount that they spend, with payback within a year for each use case. Next slide, please. So here's one case study. It's one of our networks in Norfolk, Virginia. This is the first half. The main goal of this study is to track how far tailwater flows into their system. The basic concept being that if the storm system is full of water from other sources like the ocean or the river, it does not have capacity to hold water from rain as it was designed to do, and we'll see increased surface flooding as a result. So looking at this, and considering that the capacity that we're showing here is the average over the time that we've monitored, so it's not during storm events and it's not during high tide only, you can see that pipe capacity is a significant issue. While they knew they had problems, being able to quantify it really helps them with their modeling and design for system upgrades. Next slide, please. Storm Sensors also developed an algorithm that differentiates stormwater from tailwater in real time, from which stormwater flows as well as combined sewer overflows are differentiated relative to tidal flows. So the data presented here were captured directly at an outfall utilizing the pre-production release of our tidal flow separation algorithm. The algorithm detects each of the measured combined sewer overflow events as well as higher than expected flows that are typically associated with rainfall and not with overflows. Next slide. And then if a depth or a velocity sensor goes down for whatever reason, we automatically switch to run the Manning's equation to calculate flows so our customers don't lose any of that data. And what we've done is develop an algorithm that calculates calibration constants specific to that pipe location so all of the flow estimates are as accurate as measured flows. And we're calibrating across 30 to 50 sensors within a relatively small area or a single system, so you can really track that variability. So here you can see that measured flow, and our proprietary calibrated flow at peak is about 20 cubic feet per second. However, using the uncalibrated standard Mannings results in an estimated flow of 125 cubic feet per second. So if you think about the implications, water is not necessarily moving through these systems nearly as quickly or at as high a volume as estimated, which means a lot of water is moving a lot slower, it's backing up, and it's surcharging. And it also has been able to explain why we've seen so many flooding events when these storms have been well within design storm standards for the cities that we're monitoring. Next slide. So the famous statistician, George E.P. Box, once said that all models are wrong, but some are useful. And right now, most of our efforts toward combating climate change are based only on models. Storm Sensor wants to fix that by capturing real-time empirical data within these highly variable systems. We provide the data and the insights to match models to reality. And that is what we believe cities need to create the thriving, resilient communities of tomorrow. Thank you.
Thanks, Aaron. That was great. I didn't even have to warn you on the 30 seconds. Next up, we have Gary Wong. Gary is the principal for global water industry at OSI Soft, a leader in real-time operational intelligence. He has over 20 years of extensive international experience providing sustainable, strategic, and cost-effective business solutions in the water industry. In his spare time, he is the chair of the Swan Americas Alliance. He holds degrees from the University of British Columbia and Queen's University. Gary, over to you.
Great, thanks, John. Well, welcome everyone. Next slide, please. I'm Gary Wong with OSI Soft, and I lead OSI Soft's global water business. We're a software company founded in 1980, and we are a leader in real-time operational intelligence. As you can see from here, we provide data services in real time in terms of monitoring, collecting, analyzing, and visualization of all that data to a number of different industries. If you just focus on the utilities alone, we have over 1,000 utilities around the world. Next slide, please. Now let's focus on water and how do water utilities get value from our system? You can see a number of challenges that they deal with every single day. Condition-based monitoring of their assets, managing energy costs, looking at water quality, and so forth. Obviously, a lot of data is needed in order to make the right decisions around this. And you've heard also from my colleagues today that they have these wonderful applications and hardware IoT type devices that generate a lot of data. And data is so important. So let's take a look at the next slide, please. We commissioned a survey last year, a report to look at what the industry is doing in North America. So we surveyed about 200 water wastewater utilities, and we asked them a number of questions around their data needs and the challenges that they face. So the first one that we see here is 61% of the people had difficulty in accessing their data alone. Sometimes you hear utilities talk about having too much data or a lot of different data silos. You can imagine that there's so many different solutions out there that each of these solutions can create silos onto their own. And of course, we can't automate everything, so you're going to have manual data. Next slide, please. Now, in terms of being able to make sense and provide context to all that data, it's even a bigger challenge. In terms of the integration of all that data, you can see that in the first two columns, that 75% of the respondents said that they only do a fairly well or not so well of a job at managing and integrating and using their data. So that's a lot of room for improvement. Go to the next slide. But the great thing is with the OSI Soft Pi system, we're an out-of-the-box solution that can take away this mess that you see in front of you. And this is very typical in terms of any utility or any company out there that deals with a lot of different processes. So we have our SCADA systems, you have data loggers, you have new sensors, you have metering out there. And of course, you have a lot of applications, a lot of the business applications, such as your financial systems, you have your lab for water quality, asset management, and so forth. If we go to the next slide, you can see that the OSI Soft Pi system is a platform, a data core that we call it, that's completely out of the box, that's able to integrate the data from all these different types of systems and provide the data to people and systems with the right context. Next slide. And that's true regardless of where that data exists. So when we have sensors, for example, at fire hydrants or within pipes, those are at the edge. You also have your SCADA and controls and automation systems that are within your plants. And also there's a lot more data now starting to go up into the cloud. So the Pi system is able to talk across all those different areas, across multiple different formats, and start to make sense of data for people. Next slide, please. So I'm going to talk about two examples. The first one is Hampton Roads Sanitation District that you see here. They're over in Virginia, along Virginia Beach, and they manage wastewater for about a couple million people. They get a lot of storm events, and right now we're going through storm season, for example. And what they need to do is prevent those sewer overflows and to also direct their crews to the places where they need people to respond to if there's any kind of system upset. You can see from this display from our software, the Pi Vision display here, is that they're bringing in data from a number of systems. You have radar data that's being brought in. You have the weather forecast, manual data from data loggers that are out there, weather stations, pressures, flows, and they have the ability to actually forecast and predict where they might have some of these system upsets. So they're able to act before an upset happens, or in some instances, there's not much they can do, so they know exactly where to send their crews. So this is all happening in real time, and you can see it's what we call that, one pane of glass, a simple display where you see multiple pieces of information all making sense with the right context. Next slide, please. This is the city of Salem in Oregon. With climate change, we're seeing the temperature of water rising, and unfortunately that's causing, for example, what you see here, algae blooms in some of our lakes. Detroit Lake is their main source of water, and in 2016 they had an issue where there were these algae blooms that you see, and not only do you see these blooms, but they actually can cause cyanotoxins. So these cyanotoxins are actually harmful to us and to our pets, for example. And in 2016, actually, some of these cyanotoxins got into their drinking water supply. If we go to the next slide, please. So that's something that they didn't want to happen again. So working with us and the Oregon State University and the prediction lab there, from this slide, you can see that they're bringing in data from 8 different sources. They have these pontoons out in the lakes, so that measure multiple different parameters such as pH, turbidity, temperature, and so forth. And the data is then sent along with 8 other pieces of data from different systems to this prediction lab that does using artificial intelligence and neural networks to forecast what are the probabilities and the odds of having algae blooms and also cyanotoxins. So they can forecast out 2 weeks in advance, as you see here, and they posted it online in real time so that anyone in the area can see exactly what's happening, and then they know the real situation at any given time. So with that, you can see that data is so important, and having a platform, a data core, to make sense of that data, not only for us as people, but also other systems, is critical in order for us to manage our utilities today. Back to you, John.
Awesome. Thanks, Gary. So these were all great presentations. And now it's time for question and answer. And as the moderator, I'm going to ask the first questions, then we can take some from the audience. So the first questions are, we've been talking, value from data for years. How are we demonstrating it? Are clients putting their money where their mouth is? And, what are some of the characteristics that make for great clients for you? And maybe we'll go in speaker order because we haven't heard from Rick in a while. So, Rick.
Great, thank you, John. So we have been generating that data for years. We clients stretching back more than 10 years. Many of them are all across the US and Europe. Many of them with multiple instruments. And where they're getting the value from? Well, they're reducing their operating costs. They're reducing non-compliance events. Some are actually using our instruments now in Europe for reporting. So it's just another value for them. Though for someone looking to optimize costs is less than a year often. A very rapid payback because they're driving without a speedometer, without instrumentation. And a good client is a client with a problem. A client who is not in control of their costs, is suffering excursions, and needs to get in control.
Awesome. Thanks. Tim, over to you.
Yeah, great. Thanks, John. I think what you're hearing today is the advances we've made over time in terms of data, in terms of getting better data, and in terms of the analytics that are now available to us. And I think it's getting demonstrated that we've run programs for pressure management operation of a system. So being able to operate your pumps at a different power draw. We've been able to reduce breakages due to transient mitigations. So lots of things you can start to do with the data once you have it in a format you can use, and once you have the tools to be able to analyze it and present it, as Gary said, in a way that makes it actionable and also makes it available in one pane of glass, I think was the term Gary used. And it's a perfect way to describe how we need to address data going forward. Clients tend to put their money where their mouth is when they have a regulatory problem. We prefer clients that are putting their money where their mouth is as they evolve and as they begin to digitize and think about how they're going to manage the assets that they have within their system. So a perfect client for us is not only one with a problem, but also one with a champion, someone who understands where they want to go with the data that they're going to start collecting.
Awesome. And Aaron, over to you.
Well, I think you're absolutely right. A client with a clear problem and a client with a champion is critical because a lot of what we're doing is relatively new to some people. Like a lot of cities don't have their maps in GIS yet, or their sewer systems in GIS, for example. So all of this is new to a lot of people. So someone with a vision, a problem, and the wherewithal to get it through is amazing. And then as far as how they're using the data and how they get value, we see it in a variety of ways. Everything from daily operations and maintenance, so knowing if you have a clogged tide gates stuck open, so being able to send the guys out to the field on an as-needed basis and make sure that you're able to prevent these backups and floods in real time, all the way to the predictive side and being able to prepare for these events in advance, and then also in the future for developing capital improvement projects based on really accurate information in these highly variable systems instead of relying solely on models.
Awesome. Gary, over to you.
Sure, thanks, John. Let me give you one great example. The White House Utility District in Tennessee. They've had SCADA systems for many years. They've had a GIS system for many years. And they really wanted to find leaks because they knew leaks was a major issue. So we basically helped them out, and they put in a few sensors within several district metered areas. And they provide water services for about 100,000 people. And in less than 4 days of having our system in, they found a $300,000 a year leak they never knew about. When they presented at our conference a couple of years ago, they actually interviewed the person that the leak was found on their property. That person thought it was a natural water feature. They actually went to the Home Depot and made a little feature out of it, and they said, no, sorry, it's a leak, so we're going to have to basically fix this, and it's all going to be turned off. Since then, they've for the first couple of years after that, they reduced their leaks by over $1 million, and they're able to defer $20 million in CapEx spend because they no longer had to, increase the capacity of their plant, right? So that's so important, and I think that's that time to value is absolutely critical.
Thanks. And I think the only downside is that it sounds like someone lost a koi pond out of the deal. So it looks like we've got a question from the audience. And sorry, the little box is in the. Oh, okay. So Aaron, the flow sensor and the storm sensor system is an in-house development or an OEM? If OEM, mind sharing which one?
It is an in-house development. We didn't necessarily go out with the plan of developing our own sensor, but when we started with the objective of trying to capture all this data in real time across a network. But when we looked into alternative sensors or existing sensors, both the cost and the configuration associated with it made what we wanted to build very difficult. So we ended up building our own. We have velocity using Doppler, we have depth using ultrasonic, and then temperature and ISMET.
Great. And do we have any more audience questions? If not, I can keep firing away. Looks like great. So one question to everyone is how do you make users' lives easier? I thought my maxim is always, how can I make my clients' lives easier? How do you do that? We'll go in random order this time. We'll start with Gary.
Sure, thanks, John. Yeah, that's the thing, right? We want to make their lives easier, and we want to basically make quality of life, better for everyone here. It's about providing easy access to the data that they have already. So we're not saying they need more sensors. It'd be great if they did. I think that's really important. But they can do so much more with the existing data they have. So if we're able to, and we are, very quickly provide easy access to the data with the right context so that people can understand it. As you can imagine, the context is so important. If you're getting a lot of data from these SCADA and control systems, they probably have some very archaic name like A-P115A. That means nothing to someone on the business side, right? But they know that they're looking for a pump flow or a pressure or a pH, right? Having that context is really important. So, being able to provide that easy access to the data so they don't have to say, call an IT, wait 2 weeks for a report to get generated, I think there's a lot of value there.
Awesome. And so we've got 1 minute left. We'll go to Tim and then Rick and then Aaron.
Sure. Thanks, John. I think to tie into what Gary's saying about making the data easily accessible and that, we also need to make notifications easy to receive and not inundating people with too many false positives, too many alarms that they eventually shut off. But I think people look at technology when it's first installed and then they stop looking at it. So we need a way to make sure that the system is providing them with the information they need, even if they're not staring at the screen.
I'll jump
Awesome.
in quickly.
Rick, it's over to you.
I would say that the critical issue is making sure the data they get is accurate and available, and that's our obsession. So all of these platforms require that. a few minutes for Erin.
Thank you. I would say absolutely the accurate data and also the insights that come out of it, because oftentimes someone doesn't necessarily care, for example, of the velocity within a certain pipe, but they want to know the capacity of the pipe. So we'll do capacity summaries or baseline flow analyses, so it makes it easy to get a quick snapshot of what they're looking for.
Awesome. Well, it looks like our time is up. So thank you to all the panelists. You can clap at home if you are able to. Thank you to the organizers, and thank you to the audience. We look forward to next time, and hopefully in person.
Thanks so much.
Thank you.